Welcome to Euron and welcome to our very first lecture of NLP, Natural Language Processing. So guys, in this lecture, as this is a very first lecture for all of us, I'll try to make you understand that what literally NLP is, what in all tools and technologies you are supposed to explore, what kind of a task you will be able to achieve with the help of this entire NLP, how world has moved from a conventional NLP to a latest, or you can say a modern or LLM based NLP. And not only that, I'm going to even give you a complete roadmap. So where it is going to help you out to explore all the technologies or a kind of a project in a structured way. And you can start your journey while learning this NLP, Natural Language Processing. So fine guys, let's get started. So very first thing that I would like to discuss with all of you, that what is this NLP? Why we are talking about NLP? So guys, since our ages, we as a human being interacting with other human being by using different languages, by using a different grammars, by using a different syntaxes, by using a different kind of words. And yeah, we all are able to convey our messages, our emotions, how we are feeling to other human being by using a natural language, by using a languages of our reason. And effectively, it is working since an ages. Now, so if I have to do a same thing with a machine, so that machine can understand me the way I'm looking for, machine can understand my emotion, machine can understand my feelings, machine can understand whatever I'm trying to convey, then that is called as natural language processing. So where artificially, right? Artificially, I will try to convey my messages, my thoughts to a machine. Machine can process it. Machine can try to understand it. Even though if I'm going to give an input to a machine by using a different languages, maybe English, French, Spanish, Hindi, Tamil, Telugu, whatever I want. And if machine can understand those languages, if machine can understand those dialects, if machine can understand those grammars, and if machine can give me a response while understanding all of these things, then I can say that yes, I'm able to build a natural language processing system. So NLP is all about understanding that how machine can communicate just like a human being with a human being, or maybe to a machine itself, and then do some sort of a productive task. And this area comes under NLP, a natural language processing. So now let me share my screen and let me talk about this beautiful document that I have prepared for all of you. So what is NLP? I believe we all are able to understand. So natural language processing is a field of artificial intelligence that focuses on the interaction between human and computer using a natural language, whatever language that you speak, whatever language that you understand. The goal is to enable machine to read, understand, interpret, and generate a human language. And not just that, do some sort of a task as well, whatever task I'm going to ask to my machine to do it. And I believe nowadays, because of generative AI, we are living in an era where we are able to do it successfully, right? We are able to build a lot of agentic AI systems. So where you are going to give a command, not by writing some sort of a query, not by doing some sort of program, but even though if you are not a guy who understands a programming language, by the way, Java, Python, C, C++, or any other programming language, but still you all will be able to interact with a machine, and all thanks goes to LLMs, all thanks goes to a generative AI, era of generative AI, I would say, right? So here we are living in an era, so where this natural language processing is now a reality. We are not living in an era, so where we are just talking about it, or we are saying that we are going to build it in a future, but no. We are literally leaving this era of a natural language processing, and we are able to convey our messages. We are able to convey our command just by using a language that we use in our day-to-day life. So this is the reason. This is one of the reason that NLP, or a field of NLP, is getting a lots and lots of popularity among all the fields, and everyone is trying to adopt, maybe by building some of the model, maybe by integrating some sort of a LLMs, large language models, or small language models, maybe by integrating some sort of a agents, maybe by doing any of the generative AI things that we are going to learn. Now, so what is a core objective of a NLP? So when we are talking about a NLP, so basically the core objective is to make my machine understand a human language, a syntaxes, a semantics, and a sentiment. Now, convert unstructured text into a structured data, enable machine to perform a language related task like a question answering. Yeah, the way human question and answer each and everything, translating from one language to other languages, or understanding this entire document that I have given to you and creating a summary out of it. And we are able to see that, yeah, it's a reality, right? We have a kind of a agent, we have a tools, we have a software which can come into my meeting, and it will be able to understand what one or other person is trying to speak, and it will be able to summarize. We have a Google Translator kind of a system which will be able to translate one language to other language, and that too in a real time, right? We have a kind of a system like a ChatGPT, or maybe a Cloud, maybe a Perplexity. So where I can give a simple command, maybe by making some sort of a grammatical mistake, but still it is able to understand my command and it is able to generate a response out of it. Doesn't matter what kind of a response I'm looking for. Maybe I'm looking for some sort of a coding response. Maybe I'm looking for some sort of a formula. Maybe I'm looking for some sort of a picture understanding. Each and everything now machines are capable enough to do it. So just imagine how vast this field is and how far we have already traveled in an era of NLP, a natural language processing. And this is where this NLP is very much relevant. Now, the next part which I would like to highlight over here is that what kind of an application we all can build with the help of NLP. And beautifully, I have documented these things so that everything will be in one single place in a neat and clean way. So the very first application that we are able to see all around us, whether we are interacting with the banking system, or maybe edutech like us, or maybe to some sort of some sort of a financial system we are interacting with, everywhere you will be able to find out a chatbot, right? And chatbot is nothing new. Even 5 years back, so we have been developing a lot of chatbots. But now the way chatbot is able to or capable enough to give you a response, it was not the same. Again, all thanks goes to a LLM, a large language models, or era of this entire generative AI. Now here, so chatbots is becoming more and more powerful. I can try to give a command, maybe with a voice, or maybe with a giving some sort of a picture as an input, giving some sort of a document as an input, or maybe just by writing some sort of a line in my language of my own choice. And yes, chatbot is able to understand your context. Chatbot is able to understand the grammar. Chatbot is able to understand the sentiments, and accordingly, it is giving you the answer. So one of the biggest application which you can build, or which people are already building it. And again, so many systems are already running into a production with respect to chatbots. Now, the second application or second kind of application that you can build or you can try to use is a Google Translate. I believe we all are using a Google Translate some or other way, or Google Translate kind of a system some or other way on a regular basis since a long time, right? And now these translate system is more and more powerful. So it can translate from one language to another languages, and that too nowadays without making much of mistake in terms of a syntax, in terms of a semantics, in terms of maybe a emotion that I'm trying to express. So this is another application that you can build, and it's a vast area in itself. The translation, a language translation, is a vast area because there are thousands of languages exist in our community on this planet. And yeah, so understanding all of these languages and translating it accordingly is a big task. But yes, all thanks to a Google Translate kind of a system, which is possible now. Now, the third application is a summarization. Let's suppose this document is 9-page long, and I'm not in a mood to read this entire 9-page of document. What I will do? So maybe I'll try to upload this document inside Euron, inside a ChatGPT, inside a Cloud-A, inside maybe a Perplexity. I'm going to ask that, okay, can you please summarize this entire document into 5 or 10 lines? And yes, now system will be able to do it by understanding the entire content of this document. And it's a lethal tool that we are able to build because of this kind of a tool. So let's suppose if I have a legal document, if I have a complete books, so without even going through the entire legal document, I can just ask for the summary. So the document which was taking hours on hours of time before to read out and to understand, now just because of this NLP system, we will be able to go through this document maybe in a minute or maybe just in an hour of time, right? So this is how powerful this summarizing system is. Now search, right? Search. So search is again one of the wide area. And we have been using a Google search. We have been using a Bing search. We have been using a Yahoo search engine a lot. And even Google search engine is one of the powerful one. But now with the help of NLP, you will be able to do an exact search, right? Exact search. And again, all thanks goes to NLP. Classification task. So whether a spam that we used to receive in our email system, or maybe on my mobile in my WhatsApp or SMS or text that we used to receive, or maybe we are trying to judge or we are trying to do an analysis of comments over a Facebook, over a Twitter, over a YouTube. Now, with the help of NLP, I will be able to classify that, okay, so whether the sentiment is positive, negative, neutral, or political, or something else, or I will be able to detect whether a spam or maybe a ham. So again, with the help of NLP, I can build this kind of a system. Now, the another system that you can build is a question answering system. Now, guys, I'm trying to give you all these things in a generic way. Now, all of this system that you are able to see, all of this application that you are able to see over here. Now, these applications are not specific to a domain or not specific to an individual technology. You can build all of this system. You can consume, you can use all of this system in any domain of your choice. As simple as that, right? So whether it's a classification, search, summarization, translation, or maybe a chatbot system, everyone that I have mentioned over here, including a question answering, right? Including a question answering. So maybe you have some sort of a private document. You don't want to expose those documents, but yeah, you can now build a system with the help of this NLP, with the help of this powerful LLM model, open source model, maybe offline system you can try to build. So where you can try to give all the company document or all the secure document, and then based on that document, based on the data that you have provided, you will be able to do a question and answering, right? Plus NLP will be able to recognize even a place, even a person, even organization in a beautiful manner. So this is how strong NLP is. And a speech-to-speech translation, or like a speech-to-text or text-to-speech, all of these things are possible now based out of NLP. So these are the core application that you will be able to build. Out of this, you will be able to derive hundreds of application in the technology you are working or in a domain you are going to work. So hope all of us are able to understand that what is a potential of NLP, and everywhere we are able to see it. Starting from your Alexa, your Siri, your OpenAI, ChatGPT, or maybe a Cloud-A, maybe a Perplexity, maybe a Euron, everywhere, right? So we have seen the system. So where I can give just a voice command, it is going to work for me. We have seen the system. So where we are going to ask for the translation, and it is going to work for me. We have seen a system, or we are going to, even in this class, we are going to see the system. So where you are going to ask some question, and yes, system is going to reply based on the input data that you have given. Maybe that data is available in some document, or maybe that data is available into some of your databases. That's completely fine. Even we are going to see a system. So where you can try to control a SQL. You are going to write a complete query just by giving some sort of a sentences, just by writing a couple of lines that, okay, can you please try to retrieve this particular data, that particular data, and yes, system is going to do that. So NLP is literally a lethal. It's a powerful tool that you will be able to find out, a powerful technology that you will be able to find out in this era of generative AI. So where NLP is going on another level. And since last 2.5 years, we all have seen a kind of a improvement, the kind of a innovation that has been done in this particular area. And along with this improvement, along with this innovation, it is generating a lot of opportunity for all of us, not just for techies, but even for a non-tech person and for the entire world. And that is the reason demand for this technology is very high. Everyone is trying to automate the process. Everyone is trying to build a system so where you can just write some sort of a line the way you try to ask some human being while doing a conversation, and system will be able to do the task. So we are living in that kind of an era. Now, moving ahead, so whenever we are talking about NLP, right? Whenever we are talking about the NLP and whenever we talk about building a system from the scratch, then what is the approach or what is the kind of a pipeline that we are going to build or we will be building? And this is the same approach we are going to follow even inside a class while building a different kind of a project inside this particular syllabus. So first of all, obviously, you have to give an access of a text data, a raw input data you have to give. Maybe that is coming from your databases, maybe that is coming from your documents, maybe it is coming from your email, tweets, or from anywhere, maybe from your S3, maybe from your Azure blobs. So the very first thing is basically a data input for any kind of a NLP system. Now, once you are going to give a data input, there is a possibility that there will be a mess, some sort of a mess that you have created. Maybe there are some sort of a unwanted character, unwanted punctuation, unwanted data, which is available inside your data, the raw data that you have given. Then what is the next step? So we are going to build a system. We are going to write a program, so which is going to clean those data as per my need. I'm not saying that you have to remove all the punctuation, you have to remove all the emojis, you have to remove all the special case character. No, in some of the sector, in some of the domain that will be required maybe. Yeah. So as per the domain, as per the business knowledge, as per the system that you are going to build, you have to clean the data. So it is not going to be just like a thumb rule, which you can build once and apply everywhere. No. Depends upon the system that you are trying to build, it is going to change. Now, once your data is clean, then you are going to do tokenization. Now, what is this tokenization, by the way? Yeah. So tokenization means, so let's suppose I have a long sentence and maybe I'm trying to build a system. I'm trying to train a system which will not be able to take this long sentence as an input, or maybe I'm trying to read a complete document and obviously I can't try to give a entire document as an input inside my system. So what we do is that we try to break it down into a words, into a sentences, into a paragraphs, or maybe into a single word or single letter even, right? Single letter. And then we are going to provide those input to my next system or to my next model. And that is called as tokenization. Again, there are a lot of variables we are going to see over here. So depends upon the task that I'm going to fulfill, depends upon the task which I'm going to perform. Then POS tagging, a parts of speech tagging. So the way we as a human being, whenever we try to form a sentence, so obviously we have to take care of our past tense, present tense, noun, pronoun, verb, adjective, adverb, all of these things. So in the similar manner, to make my machine, artificial machine, understands the relationship between all those punctuations, all those grammars, all those parts of a speech. So we have to do a parts of speech tagging so that my machine will be able to understand the way we as a human being will be able to understand. So again, parts of tagging comes into a picture, NER, name entity recognition comes into a picture. So you have to tell machine that, okay, so this is particularly a name I'm talking about, a person name, a company name, a corporate name, organization name, institution name. So you have to talk about that. right? You have to talk about that, and you have to give some sort of an input to your machine so that it will be able to build a relationship. Accordingly, it will be able to learn. And that's a base. That's a base for any kind of NLP system that you are going to create. Now, dependency parsing. So obviously a grammatical things you have to parse. And then there is something called as vectorization and embeddings. Now, the problem with machine is, guys, that machine can only understands a numerical representation. It is not going to understand your words. It is not going to understand your grammar or punctuation. So whatever at this, till this stage, right? Till last stage is completely fine. But at this stage, when you are trying to prepare a data for your machine so that you can train a machine, so that machine will be able to interpret and understand, you have to convert your data into a numerical representation, because machine can only understands a relationship which is available in a numerical format. Because at the end of the day, for everything that you are going to build with a machine is going to treat it as a numerical entity. It will be able to apply some sort of a mathematical formula only with respect to a numerical entity that you are going to pass, a numerical data that you are going to provide. So here, in this layer, we try to convert our data by using a different kind of a mechanism, by using a different kind of a algorithm, which has already been established. And as per my use case, and we used to convert our data set into a numerical representation, into a vector space where we'll be having a magnitude as well as dimension in 2D, 3D, or maybe a n dimension. We are going to convert our data, and then we are going to pass our data to the next stage. And that next stage is basically a model, a modeling, by the way. Yeah. So where based on the task, let's suppose I'm trying to perform a summarization task. I'm trying to perform a classification, a spam and ham kind of a task, or maybe a sentiment analysis kind of a task I'm going to perform, or maybe question answering kind of a task I'm going to perform. So for that respective task, that particular task, we are going to choose a model, right? That, okay, I'm going to train this model. Model means what? Model means a mathematical, you can say architecture, a formula, right? A mathematical formula. As of now, you can try to understand in that way. As we will go deeper and deeper, obviously our understanding will be very much clear. So we are going to choose a model, a machine learning model, maybe a deep learning model. We are going to choose it, a neural network. We are going to choose it, and we are going to pass our data, the data that we have prepared on point number 7, to this particular model for a respective task, and we are going to train it. Now, once we are going to train the model, so obviously model will be ready to give you some sort of a output. But majority of time, because of hallucination, because model is basically doing all sort of a calculation. So based on the numerical information, it is trying to understand a relationship between a word or maybe a grammar or sentences or punctuation. And based on that, it is going to give you a response. So you have to go through a formatting of a data, so that as a human being, you will be able to read out, you will be able to understand. So that is something called as post-processing basically. So this is the pipeline, guys, in general we are going to follow, and hope all of you are able to understand that how any kind of in general, this is going to change a lot as you will start building a different kind of application. Believe me, it is going to change. It is not going to be same at all. So here, this is the overall NLP pipeline that you all will be able to get. Now coming to the next part, guys. So what is the difference between the NLP that we have been using, or a neural network based NLP, and now we are talking about LLMs basically. So what is the difference between that? So the previous NLP, or classical NLP, I would say, was based out of the rule if else kind of a situation. So where if this is going to happen, then do this kind of a situation. Now eventually, like a couple of years back, this neural network based NLP comes into a picture, so which can build a relationship between a data set, and we are going to understand that in a depth, in a very depth we are going to understand. And that is something called as neural NLP. And now since last 2.5 years, 3 years, so we are able to see a large language based NLP, which is again an extension of a neural network based NLP itself. So this is nothing different, I would say. It's an extension of this neural NLP itself. So where we are using a transformer based architecture. Now, what is this transformer based architecture? So it's again one kind of a powerful neural network which can understand NLP based data, which can understand this raw data. It's like a relationship in between, and which will be able to eventually give you an output for a respective task. That is something called as transformer, and in a beautiful manner. I have already discussed this transformer architecture multiple times in my classes. So in a beautiful manner, step by step, just like a layman, we are going to understand a transformer architecture. Now, example wise, POS tagging, like a TF-IDF. So basically it's a like a or regex basically. So these are basically like a, which comes under like a classical NLP. So where there was a static formula, and based on those static formulas, so we were trying to do something, right? It was not a dynamic at all. So TF-IDF means a term frequency, inverse document frequency. I'll be talking about that formula as well. That's a part of your syllabus. Then a neural network based NLP comes into a picture. So where word to vector, LSTM, long short term memory, or by LSTM, so by long short term memory comes into a picture. And then now we are living in an era of LLM. So where we talk about a GPT kind of a model, BERT kind of a model, T5 kind of a model, Cloud Edge Gemini kind of a model. And I believe now it's a reality. We all are, whether we understand NLP or not, but yeah, we all are using it, right? We all are using it effectively. Now, language understanding was very much limited in case of a classical one, because it was a rule based, and language itself is a vast area. The line which I'm able to say, maybe if I'm going to ask you to say the same thing, maybe you will be using a different phrases, different grammar, different combination, and then you are going to say that, right? So here classical NLP has failed, and it was not able to interpret the way today we are able to see a system can interpret. Now, better context handling and deep learning based. So it is able to understand a long format of the sentences, but now we are in an era of LLM, so which is even understand a deeper contextual understanding in between the data set. Our data need was very low again in case of natural language. So it depends like what kind of a system that we are trying to build. But in case of LLMs, it's a massive. You need a entire, if you have to build a best of best system, you need an entire data set which is available over internet, and that too the data set that we have produced over a year, or I would say preferably I will say that over the decade that we have produced. Now, explainability. So yeah, you can explain like how system is working. In case of NLP, a little bit difficult to explain, but yeah, more like you will be able to do some sort of a calculation. But if I'll talk about LLMs, it's kind of a black box in nature, but I'll try to unwrap that black box for all of you. Right, I'll try to unwrap those black box as much as I can, right, as per the limitation of this entire like a transformer based architecture. So till that, obviously we are going to unwrap it, and we are going to understand that how LLMs has been actually built. Now, customization was easy. Here it's not, it was medium, like not as easy as a classical NLP. And in case of LLMs, you can do a fine tuning. So based on the already trained model, you can try to fine tune it with respect to our own data set. And not just that, you can even try to like train it from the scratch. But yes, you need a massive computation, and you need a massive amount of a data set, even if you are going to build a basic model. Now, speed was very fast, then moderated, and then it's slower. So obviously it needs a high computation. So where GPU, graphical processing unit, or TPU, tensor processing unit, come into a picture. Now, let's talk about our popular NLP tools and libraries. So since ages, we have been using this library called as NLTK, Natural Language Toolkit. It is good in terms of cleaning our data, in terms of, processing some of the parts of a speech or name entity recognition. It was not that good, right? It was not that good. Then there is a library called as Spacey comes into a picture, and it was industry grade back then, maybe 2 or 3 years back. Then there is something called as Hugging Face Transformer. So Hugging Face is basically a platform, so which provides you a repository, so where you will be able to find out all kind of a model, not just transform based model, but yeah, even a computer vision based model, or even like a machine learning based model, NLP based model, you will be able to find out over there. And obviously Hugging Face is going to provide you a lot of transformer model as well, which we are going to learn, which we are going to study. Scikit-learn, a evergreen library for a machine learning people, right? And you will be able to use any of this machine learning which is available inside a scikit-learn, and then you can build a basic system. I'll not say that you can build an advanced system, but yeah, basic system you will be able to build, because now we are living in a very different era. And then a TensorFlow and PyTorch. TensorFlow by Google and PyTorch by Facebook. So these are the open source library which is going to give you a power, a capabilities to build anything from a scratch. So whether it's a basic NLP classification system or maybe a transformer based system, all of these things you will be able to build. And in real time, people are using these libraries to build anything or any LLM that you are able to see nowadays or you interact on a daily basis. So hope this library part is clear, and we are going to cover all of these library in a step-by-step manner. Now, coming to a roadmap part. So anyone who is trying to start ahead with a NLP, what you should learn and what should be your approach. To make these things very clear, guys, whenever you are starting anything inside a AI, the very first part is a programming language. Without programming language, you will not be able to learn anything. And that is the reason. So we have multiple lectures, we have multiple modules on just a Python, so that you will be able to build a basic understanding, a basic logic, just with the help of Python programming language, because throughout the syllabus, I'll be using that language. Whatever libraries which I'm going to use inside this entire lecture, all of those libraries are going to be a Python based library, whether it's a TensorFlow or maybe a PyTorch, maybe NLTK, maybe a scikit-learn, or maybe a Spacey, anything that I'm going to use. So that is going to be a Python based. And even when you will go out, you will start building some solution or building some project for your resume or for your next client, you are going to use some programming language. And Python is one of the most popular, most important, and most easy to learn, easy to adopt programming language for any AI guy, right? Anyone who would like to get into a field of AI. So Python is something that we are going to explore. Then we are going to explore our text pre-processing. I think I have already cleared this out in your pipeline segment, right? In your pipeline segment, so I have already discussed about it. So same thing I'm talking over here, even in terms of a syllabus. And I have like I mentioned, couple of like low-level topics as well, which you can go through it. Text representation technique means converting your textual data into a numerical information. And for that, so we are going to use our different technologies. Some of them are going to be a rule-based, some of them are going to be a neural network-based, and some of them are going to be a transformer-based, which is a cutting-edge and latest one. Now, coming to our next part. So here, when you are aware about till this particular point, so then you have to talk about a core NLP. So whatever task which I have listed down in a very beginning of this entire discussion, so we will start building, or if you are trying to learn, so you should start building, you start learning those algorithms, and you should start building those solutions. And this is where a core NLP task comes into a picture. So whether it's a parts of a speech, whether it's a checking, whether it's a NER, whether it's a classification, or whether it's a sentiment analysis, topic modeling, summarization, question answering, anything means anything, right? Anything. Then the next part is machine learning and deep learning for NLP you are supposed to understand. Because if I'm trying to build some of the classification model, so obviously those are going to come from a machine learning, like a naive Bayes, logistic, SVM, and a random forest, XGBoost as well. Yeah. And then you have to understand a couple of things from deep learning, like starting from RNN series, which comes with the LSTM and GRU, then attention mechanism, sequence to sequence, transformer. So all of these things you are supposed to understand. Then the next part is a large language model, which is the latest one, which is the cutting edge one. Now, many people ask me a question that, can I directly jump into a generative AI? My answer to all of you is that no, you should not. Because see, generative AI is not just about using LLMs directly or calling some sort of an API or maybe installing some sort of a pre-built open source model. No, not at all. Not like that. Because when you will be a part of industry, you will be having your custom application, and you have to use all of these technologies which I have mentioned inside this slide to develop or to solve your own custom problem for your own domain by using your own technology. So jumping directly into a large language model as a NLP engineer, or even as a generative AI engineer, which is getting very much popularity nowadays, it's not a good deal. It's not a good idea. So you should not jump into this one. But yeah, so if you are able to cover till point number 5, then obviously you can jump into this one, because this is the latest one and you should leverage. I'm not saying that always keep on using a conventional NLP system. No, not at all. Always try to use just a neural based system. No, not at all. You should utilize a current power of all of these LLMs to solve any of the given problem in an efficient way, in a modern way. But before jumping into this, there is a prerequisite that you have to go through. So large language model. Now here, so a lot of things comes into a picture, and I have already mentioned it. I don't want to take a name because again, it will be overwhelming for all of us. That's the reason. So I'm sharing this document so that you can refer to this document. And when I'm going to go ahead with the lecture step-by-step manner, you can try to follow along. You can just come over here and tick, tick, tick that, okay, this is done, this is done, this is done, right? So in this manner, you should focus and you should move ahead. Then at the end of the day, a project with a real world application. So maybe a sentiment analyzer, maybe a resume matcher, maybe a new summarizer, and all of these projects which I have listed down. We have all of this project even now on the platform. If you're going to search, you will be able to find out. And again, I will be discussing about these kind of a project by using some different challenges, by using some different problem statement in this particular class as well. Yeah, and then obviously you have to deploy those solutions. So here is a deployment part. Now there are multiple different kind of a deployment strategy that I can go and I can try to explore and I can try to follow. As simple as that. Yeah. Then this is just an optional one. So if you are done with the above part till a project and a deployment, and after making it scalable, then you can come over here and then you can try to explore a extended part of a NLP, where speech to text, text to speech, image captioning means understanding images and then trying to talk about something, a vision language model. All of these things you can explore, and there are many more things you will get to know in between this particular journey, right? So hope I'm able to give you a clear understanding about a roadmap. Now here is a week-wise breakdown, because many of my students have asked me that, can you please try to give me a weekly breakdown, like how much time tentatively, because see, learning curve is not going to be same for all of us. So many of my students have asked me that, can you please tentatively give me like how much time we should spend on which particular part. So here is a weekly breakdown I have given to you. You may try to complete it before, or maybe you can take a bit longer. That's completely fine. That's up to you. But at the end of the day, objectives should be to understand NLP till its core, starting from a classical one till a modern one, and build some solution. Build some solution which you can mention inside your resume. Build some solution which can solve a real-time problem for your client or for your business. Build some sort of a solution where you will be able to launch something on your own startup. You can try to start giving services to your user, right? So that's the whole idea, guys, and hope I'm able to make sense with respect to this entire roadmap. And a basic of NLP is already available inside your dashboard. You can go ahead, you can download it, you can keep it with yourself, and then let me know if you have any kind of a question in your group or anywhere you want. With that, thank you so much, everyone. Take care. See you again. And let's begin with a NLP master, a natural language processing master. Let's try to build something together. Thank you. Okay, so welcome to lecture, everyone. And in this lecture, guys, I'm going to show you a very important part for a NLP, which is called as text pre-processing. Now, as a part of text pre-processing, what do we do? So generally, we try to remove punctuation, we try to remove hashtags, we try to remove maybe emojis, we try to convert all the data into a lower cases. We try to perform maybe a stemming or maybe a lemmatization, a lot of regular expression we try to perform on top of the data set, a lot of string based operation we try to perform on top of the data set. So one by one, by taking an example, so I'm going to explain you all of these things so that you will be able to build your understanding, and going forward, so you all will be able to perform text pre-processing before jumping into any kind of a model use case or any kind of a use case that you are going to solve with respect to NLP. So let me share my screen, and yeah, so here I can try to create a file called as text underscore pre processing.ipynb, and one by one I'm going to show you guys that how this text pre-processing is going to happen so that you all will be able to do it. Plus I'm going to attach an assignment. By doing an assignment, you will be able to understand even things in a much better way. So here, to do a text pre-processing in a very first place, so we have to basically install a couple of things inside your environment. So unless and until those things are not installed, you will not be able to do a text pre-processing. So what I'm going to install, so I'm going to write pip install install pip install, and then I'm going to install NLTK, Natural Language Toolkit library. That's a very first part. Spacey, which is again similar to a NLTK library, you will be able to find out. So I'm going to install that one. I'm going to install EMO JI so that I will be able to play with the emojis. I will be able to remove emojis. This library is going to help me out with that. And then I'm going to install a library called as contraction, CONTRACTION, so that what contraction does. So basically this library is going to help you out to expand a word. For example, if I'm writing don't, right, DON and then hyphen and T, so it is going to convert that into do not. Right, so let's, if I'm saying, so let us, it is going to convert. This is what contraction is going to do. So let's execute, and if everything is going to be fine, then this library will be installed automatically in my current environment. So let me install this library, guys, one by one. So NLTK, spacey, emoji, and a contraction. So we'll have to wait for maybe a couple of seconds, and then this entire things will be installed automatically. So taking a little bit longer, but that's completely fine. I can wait for it. Okay, could not find a version that satisfies the requirement. Version is equal to none. No matching distribution found. So let me check for which one it is giving me an error. So it's a contraction, CONTRACTIONS. Let me try installing once again. Okay, so again we'll have to wait for a couple of seconds, and this time I believe everything is installed, it seems. Yes, so everything is installed, guys, and these are the libraries that I'm going to need to do this entire text pre-processing, or you can say a text cleaning. Now once my library is installed, I'm going to consider a text which I'm going to use it for doing a different kind of a operation. So here I'm going to create a variable called as text variable, and inside that, so I'm going to hold a string, so which will be having a lot of things, and whatever things will not be having, so we'll try to add those things on top of this string data. So as you can see that inside this string, I have emojis, I have a hashtag, I have exclamation marks, I have and many more things. Maybe I can try to add some sort of a punctuation as well, right? So that whenever I'm going to perform these operations, so I will be able to even show you those. And let me add some extra spaces in between, maybe. So after and then before, then in between. So maybe I can try to add some of the extra spaces. Okay. So this rocket emoji, and then Euron offer 50 plus self-placed, self-paced AI and data science courses, hashtag AI, hashtag learning. Now this is the data which I'm going to prepare, and as you can see that this data is not available in a well structured format. There are a lot of ambiguities, there are a lot of noises that we have inside this data, and this is where a text pre-processing comes into a picture. So text pre-processing is going to help you out in terms of cleaning all of these data and then making your data ready for any kind of a task that you are going to perform going forward. Okay, that's great. Now So installation is done. I'm able to prepare my data set. Now let's do one thing. So let's try to call, or let's try to import all the required library for this entire operation. So I'm going to import basically a regex, so RE. Then I'm going to import library called as string. Then I'm going to import a library called as NLTK, which I have installed just now. Then I'm going to import a library called as Spacey, again I have installed. Emoji, again I have installed, and contraction, CONTRACTIONS, contraction. So these are the libraries that I'm going to install. Okay, sorry, import. So I have already done the installation, so I'm going to import this library this particular point of time. Now another library that I'm going to import is so NLTK dot corpus, so corpus, and import a stop word, STOPWORDS, stop words. So see guys, the NLTK library that we are using, or a Spacey library that we are using, so by default inside this library someone has already created a complete set, or you can say a bunch of the stop words. All the stop words like a is, a, the, all these stop words are already available. So I can try to use those stop words while doing a text pre-processing, or maybe I can try to create a list of my own stop words. That's completely fine. So either way, it's going to be completely same. Now, so the next import that I'm going to do is from nltk.stem, so stem, and I'm going to import some of the stemmer. So here there is something called as Potter stemmer. There is something called as snowball stemmer. Potter stemmer, there is something called as snowball stemmer, there is something called as even lens carter, but I'm not going to import it. Both are like, all these stemmers are same. I'm going to even talk about that what these stemmers are going to do. So basically they are going to convert a words into a base word. This is what a stemmer does. I'll try to show you an example for that, so don't worry. So just try to do an import as of now, and then sit tight, and then keep on doing a coding along with me. Now, so then I'm going to use again an NLTK, and this time I'm going to import a tokenize, and out of this tokenize I'm going to import a word tokenize, and I'm going to import a sentence tokenize. Tokenize means so converting my data into a small chunk, maybe a set of the word, maybe set of the sentences. Again, I'm going to show you all of these operations and examples. Now from Spacey, as we have done the installation of a Spacey, so language.english we have, so it supports a multiple languages, by the way, and inside the English language, so whatever stop words library that they have already created, I can try to use it the way I'm going to use it for NLTK. So in the similar way, I can try to use it even for a Spacey. Depends upon me, but yeah, I will be able to use it. So here, import what? So import basically a stop words as a Spacey underscore STOPWORDS, stop words. Simple, right? So this is something which I'm going to use. If you don't want to use it, again, that's completely fine. You can try to create your own list, because at the end of the day, this is just going to provide you a pre-built list of the stop words like a, is, the, that, all this stop words, which occurs inside any kind of English sentences multiple times. So this is called as stop words. Now, just execute it, and yes, all the imports are successful, means all the imports are done. Now what we are supposed to do, so let's start writing some of the code over here, and one by one. So we will start doing a text pre-processing. So first of all, let's suppose this is the data which is given to me. Yeah, this is the data which is given to me. So text data which is given to me. Now, so I have to normalize this data. So maybe I can try to convert this entire data into a lowercase. How I can do that? So simple, it's a string, and a string is having a lower function, lower as a function. So I can try to call text dot and then lower, and this is eventually going to convert my entire data into a lower cases, because some of the data was available into an uppercase, some of the data will be available into an lower cases, and if you are trying to do something which is case sensitive, in that case we can try to convert everything into a lower cases or everything into an upper cases, depends upon me. Okay, so here what I'm trying to do, I'm just trying to call a string function. This lower is basically a string function. So this is a string, text is basically a string, right? So this is like a string. If you're going to check a type, what is the type of the text? So what is a type of basically text? So type of text is what? Type of text is basically string. So I'm just trying to call text.lower, and eventually it is trying to convert everything into a lower cases. And I'm going to hold it inside a variable called as text. I'm just trying to override my same text. Okay. Now, once this is done, right? So now this is how my text looks like. Everything is in a lowercase. This is how it will look like. Now, what I can do is I can try to call a contraction over here. Yeah. So I can try to call a contraction over here. Now, what contraction does, by the way? So for example, I don't have any kind of a data inside this one. So where I can show you a contraction example. So maybe I can try to introduce some of the data. So let's suppose if I'm going to write over here, let's kind of a things. Yeah. So I've written like a let's over here, and maybe I'm trying to write something called as I is and isn't, right? Isn't. If I'm going to write isn't over here. So now ISNT isn't over here. Now, if I'm going to call a contraction on top of this data, let's see what is going to happen on top of this data. Now, so I'm going to call a contraction. So contraction import that I have done. So CONTRACTIONS contraction dot, I can try to call a fix, and then I'm going to pass my text data over here. Now, so when I'm trying to pass my contraction text in this particular place, so it is not able to perform much of the operation. Yeah, it is not able to perform much of the operation. My expectation was very different. My expectation was that it is going to convert this let's into let us and isn't into is not, but it is not able to convert that part. Now, what is wrong with that? What is wrong with that? Let's try to figure it out. What is wrong with that? So maybe I can try to change the pattern of my data. So here I'm going to enclose it within double quotes and the internal one into a single quotes. And this time you will be able to see that yes, it has converted let's into let us and then isn't into is not. This is what contraction does. But again, so the mistake that I have made in my previous run, so you are not supposed to do the same mistake. You have to enclose this entire string into a double quotes, and then internally, so you are supposed to use a single quotes. If there is a double quotes, it will not be able to recognize. That's a problem. And this is what contraction is doing, guys. So here it is trying to convert let's into let us and isn't into is not. So it's trying to expand it. It's trying to expand it. So whatever data which was contracted, so it is just trying to expand that part. So here I can try to override my text and then store it once again. So fine, this is done. So contraction I am able to perform. Now inside my text information, I have emoji, right? I have this kind of a emoji. Maybe I have one emoji or maybe I have a multiple emoji. How I will be able to deal with that? How I will be able to remove or clean an emoji out of my entire data? For that, if you remember, so we have already done an import of emoji and we have already done an installation of a emoji, right? In the beginning itself, so we have already done an installation of a emoji. So here, if I have to deal with the emoji, simply I can try to call one thing that emo emoji dot, and then here I can try to call replace emoji. Now you can try to pass your data. So I can try to pass my text and then replace with what? So with what you would like to replace. So I would like to replace with a blank string, right? I would like to replace with a blank string. And as you can see, this rocket symbol has gone. This rocket symbol has gone. So in this way, I'm able to deal with the emoji. And let me store it into a text once again, override my text. So here, now I'm able to remove even my emoji out of my textual data. As simple as that. Okay. Now, next part is, so I have a hashtag. So hashtag AI and hashtag learning is given to me. And I would like to remove this hashtag. So how I can remove it? So let's try to understand. So maybe we can try to use a regular expression over here, a regex over here. So which is going to understand the pattern of an hashtag or pattern that we are trying to introduce. And accordingly, it is going to remove that hashtag. So even over here, I'm going to use basically a regular expression. So here RE, so RE is something that we have done, and then substitute bot. So here I'm going to write a pattern that wherever you are able to find out a pattern, so just try to replace it with something, right? Maybe with the blank string, maybe with something else. Depends upon me, but yeah, so just try to replace it. So how I will be able to write a pattern for a hashtag? So here just try to write in this way. So hashtag slash W and then plus. So wherever inside our data you are able to find out this kind of a pattern, hashtag kind of a pattern inside a word. So do one thing. So just try to remove it, and remove in what data? So into a textual data. Now you must be able to see that it has gone. The hashtag word itself has gone automatically, right? It has gone automatically. So hashtag AI has gone and hashtag learning has gone. Very simple, right? Very simple. So with the help of regex, I can try to write any kind of a pattern and it will be able to remove it. Even if I am going to write like a detect email ID, or maybe detect a phone number, or maybe a country code, that is possible. And nowadays, even that is possible with the help of LLMs. LLMs are very smart. Smarter than your regular expression, by the way. So LLMs are going to work well with respect to like all the data set in a very generalized way. But yes, you can even try to use a regular expression over here. So okay, let's try to call a text, and let's try to override it. Now this is how my text looks like now, right? So I'm able to remove an emoji, I'm able to remove my hashtag, I'm able to even expand this let's and isn't into a let us and is not. I'm able to convert everything into a lower cases. That's completely fine. So a lot of operations we are able to already do it. A lot of operations we have already done that. Okay, now, so coming to the next, inside this particular data, so we have a couple of punctuation marks, exclamation, or maybe a full stop, maybe a comma I have, right? Again over here, so we have a comma, and I would like to remove this entire things. I don't want any of this punctuation inside my data set. So what I can do, how I will be able to remove it? Let's try to understand that part. So I'm going to call my text data, and then I'm going to call a translate operation on top of this, and then inside this translate, right? Inside this translate operation, so here we are supposed to mention a translate table, and then it will eventually try to replace something. So how? Let's try to understand. So string dot and then make translate function I'm going to call inside this, and here, so I'm going to say that, okay, so do this with this and a string string dot punctuation, So here, let me execute this particular part, and here you can see that all the punctuations are gone. All the punctuations are basically gone over here. Yes, all the punctuations are gone automatically. So I'm able to even clean all the punctuation marks from my data set. So let me store this data. So here I'm going to store this data text inside a text itself. Okay. Now, so once this punctuation marks has been removed, now what we can do is, so we can try to even do a tokenization. So how I will be able to do a tokenization? What is the meaning of a tokenization? So let me try to explain you how I will be able to do a tokenization. So here there is something called a sentence tokenizer, and if I'm going to pass my text data over here, so it will be able to take the entire, right? It will be able to take the entire data, and then it is going to give you the final list of the information. Now there is a one catch over here, right? There is one catch over here. So I'm going to take this data once again, and I'm going to basically consider this line, and here, so I'm going to place a comma, as we have already removed the punctuation. So now there is no comma over here. So here I'm going to use a comma. Now I'll show you. So what it is going to do, sentence tokenizer, and then inside that I'm going to pass a text. Text is equals to text. Now you must be able to see something different over here, but no. Okay, so by mistake I have taken comma. I was supposed to take a full stop over here. Now I am supposed to take like a dot over here. Let me override this, and now I'm going to show you something in this particular place, but still it's not working. It should, by the way. Okay, so there is some issue. It is not able to split it. I have tested with some other data and it was working, but with this data it is not working. My observation says that it will be able to split this data into two sentences if it is going to observe maybe exclamation marks, maybe a comma, maybe a question mark, or maybe a full stop if there is a space after that. So let me try with the space, and yeah, it is working now. After that, So that there was no space, right? So it was considering that, okay, fine. So it was a part of the same sentence. So it was not able to split. So if there is a space, it will be able to split. Let's suppose I'm not putting up a space and I'm putting this data with the capital, right? So let's see whether it is going to split it or not. No. So the space is important, guys. So here you have to give a space, and then as you can see, so it is trying to split this one and this one into two different sentences. So this is one of my sentence and this is one of my sentence. So it is trying to give me a list of two sentences. So this is how this splitter is going to work, by the way. Yeah, work by the way. So which is like a by default inbuilt function which is available inside your NLTK. Okay. So we are able to perform a sentence tokenizer over here. Now, so we can try to even work on a word tokenization. So let's see. So how word tokenization is going to work. So word tokenizer I'm going to call it's a simpler than the previous one. So here what it will do is, so whatever word that we have, like we have Euron, we have offer, we have 50, we have self-paced, we have AI, we have like a dot, we have data, science, courses, let us, is not. So you can see that it is able to convert each and everything into a one single word. So it is going to return you a list of the words or whatever data that you have. So whatever like a string that you have. So even though you have like a punctuation mark, so it is going to return you that particular part. So this is how this word tokenization is going to work. Sentence tokenization is a bit different. So condition was a bit different, and based on that, it is going to behave. Based on that, it is going to work. Okay, now. So now let's we are able to perform the sentence tokenization. We are able to perform a word tokenization. Now let's try to do one thing. So we have to remove maybe a stop word. So for example, maybe is we have to remove from this one, not we have to remove from this one. So these kind of words are called as basically stop words. Yeah, stop words. Now if I'm going to print stop words, by the way, so stop, stop words. So it is going to give me, so this is just an object. So stop words dot raw, let me call. Okay, so it is giving me like a very long sentence. So stop words as a function, if I'm going to call, no, it's not working. So stop words dot words I can try to call, and yeah, so these are the stop words which is by default available inside this stop words library, right? This stop word library, these are the words which is already available. Now I can try to use this library. I can try to use this library, and whatever is available inside this library, if something is matching inside my sentence, I can try to stop it, or I can try to remove it. I can try to simply remove it. Now, so this is a inbuilt one. We can try to go ahead and we can try to even download all the latest stop words which is available inside a NLTK library. How we can download it? So I can write over here NLTK. So NLTK dot I can call download. So NLTK download, and here so I can try to give basically stop WRDS, stop words. So what it will do, it will try to download all the stop words which is available, and then again I can try to check stop words dot words, and this is again the same. So it has already downloaded, I believe, when I have installed it. So now let's try to implement this entire things on top of my data set. So, and we'll try to see that whether it is able to remove my stop words or not. Yeah. So whether it will be able to remove something from my stop words or not. Maybe I can even try to check that is in stop words dot word. This is the list. So it is going to give me true or false. So yeah, is available. Is available. I can even try to check for the. So the is available. So yeah, even the is available inside the stop word. So I told you, right? So all this data which is available inside this particular list, I can try to perform a multiple operation. So these are the data which is available. I can even try to check that how many stop words are available. So maybe I can try to call a length of this one. So there are 11,009 stop words which is available inside this pre-built library. Again, I'm not saying that you should always go ahead and use this particular library. It's completely fine. You can try to create your own list of the stop words, and then you can try to use it. It's up to you. It's completely up to you. I'm not saying that go ahead with the NLTK or go ahead with the Spacey. These are just old pre-built libraries which is available. So where stop words are given to you, but yeah, you can try to go ahead with your own. That's completely fine. Now, if I have to remove the stop words from my data set, right? So if I have to remove stop words from my data set, what I can do is, so maybe I can try to use this tokenized one. So maybe I can try to use this tokenized one. Maybe I can try to store this word, a tokenized one. And let me print this. So word. So this is my data. Now from this data, if I have to remove the stop words, what I can do? So maybe I can try to write a loop over here. So I can try to write for W in word basically, right? If W is not in stop words, stop words dot WRDS. So I'm just writing a comprehension over here. So in that case, return me that particular word. Simple. Return me that particular list of the words. So for W in word, so it will try to go through this entire things. So whatever is available. And I'm trying to check if W is not in, right? W not in, not is. So W not in this stop words. So in that case, return that word. If it is available in the stop words, don't return me that part. So here you will be able to find out that it has removed what? It has removed basically let us, is, and not. Yes, it has removed let us, is, and not. It has even removed AI part from this one, as you can see, because this was the part of this particular stop words list that I have downloaded, or which was available at the time of even NLTK installation. So you can try to go ahead in this way, as simple as that. So maybe I can try to use a NLTK library for removing a stop words, or I can try to use maybe a Spacy library for removing the stop words. Or the best way is I can try to prepare my own list of the stop words as per my own data. So maybe I'm not dealing with the English, maybe I'm dealing with the French, or maybe a Spanish, maybe some different one. So for each and every languages, stop word lists are already available over the internet on a multiple places. So maybe I can try to take that list. And this is just a list operation, guys, that we are doing, right? This is a list which is going to return. And I'm just trying to check with respect to a list. Nothing much I'm trying to perform over here. Okay, now... So here we had a text information. So we had this text information. Now, if I have to remove a extra space, right? Now, if I have to remove an extra white space out of this data, because I can see there are a lot of white spaces in between the data. So how I can remove it? I can write a regular expression. So regular reg dot substitute, and substitute what? So substitute for a white space. Now, what should be the regular expression for white space? Let me write it down. So slash s plus, right? Slash s plus. So basically it will try to identify the extra white space, and then I'm going to replace it with a blank, and on top of this a text data. So here you must be able to see that it has collapsed all the spaces. Now let me put one space at least in between so that my data should be clean, looks like clean. So I had this kind of a data, as you can see, and which was disturbing me, which was not that readable. But yes, after performing this operation, so my data set is quite readable. So maybe I can try to store it as a CLEANED, cleaned data. Okay, so I'm able to remove this spaces, guys. Yeah, so I'm able to remove this spaces out of this one, and let me try to show you that part. Okay, now I have some digits in between my data set, and I don't want this particular digit inside my data set. So how I will be able to remove it? Again, I can try to take a help of maybe like a regular expression, and then with the help of that I will be able to remove it. So regex dot substitute. So you can write a regex technically for anything and everything. So here for removing a digits, I can try to write maybe a slash D for digit. So wherever you are able to find out this digit, just do one thing. So try to replace it with a no space, and here I'm going to pass my text data. Sorry, not text data. Let me pass this clean data so that my data set will look like a bit formatted. So here you can see that 50 is gone. Yeah, 50 is gone. So here in this way, I'm able to remove basically digits out of this one. Okay, that's completely fine. So these are the operation, guys. I believe we are able to perform back to back, back to back, back to back. Now let's try to perform some sort of a stemming operation. Yeah, stemming operation. So what a stemming operation does? So it will always try to convert any kind of a data into its root word. Root word means, let's suppose if I'm writing learning, N-I-N-G, learning. So learning is a part of my data. So what it will do, it will try to convert into its base word. So what is the base word? Base word is basically a learn. So learning, it is going to convert into a learn. This is what it is going to do as a part of the stemming operation. So there is a Potter stemmer and there is a snowball stemmer. There is also called as a lens Carter stemmer. I'm going to use two. You can try to use any of these. But again, one thing I would like to tell you about these stemmers, that it's not always going to give you the accurate result. It is going to give you some sort of an ambiguous result. So you should be ready for that particular part as well. It is not always going to give you the correct result. So you can't come and blame that you were saying that it is going to convert everything into a base word and it is not doing it for me. So yeah, there is a possibility, right? There is a possibility that it is not going to perform that particular part. Okay, now let me do this. So here, let me prepare a data for this one. So I need a list of the words. So here, the clean data that we are able to get. So the clean data that I am able to get. So what I can do is I can try to call maybe a word tokenizer, and I can try to tokenize this entire data. So I know that it is going to give me a list of the individual words. So here, data, right? Data. As a data, I'm going to store. Now, this is how my data set looks like. This is how my data looks like. Okay. So this is my data. Now, what I will do is I'll try to call a stemmer on top of this one. So I can try to call maybe a Potter stemmer. I can try to call maybe a snowball stemmer. So here, Potter stemmer. So the stemmer which I have like imported .stem. So Potter stemmer .stem, and I can try to pass my data. For example, I'll try to show you example. So let's suppose if I'm going to pass L-E-A-R-N-I-N-G, learning. Now, so one missing positional argument it requires. I am trying to provide Potter stemmer.stem. So yeah, I'm able to provide a data, but it should not give me an error, by the way. No. Okay, it should work. Okay, so maybe it's a class. So I have to create an object of this one in a very first place. So let me create an object. So here, STE stemmer object I'm going to create, and then if I'm going to call a stemmer, whatever object that I have created, so .stem stem, and now if I'm going to pass my data learning, learning. Okay, so now it's working. Just I had to create the object first and then I have to call it. So basically it was like a class method. So for a class method, so I have to basically create an object first. Okay. So here stemmer.stem, I'm trying to pass a learning, and it is able to convert my data into a learns. Now what I will do is one by one, I'll try to pass all of this data and we'll see so what it is going to perform or what it is going to do with respect to this particular data set. So here I can try to write for I in data. So one by one try to extract a data, right? One by one try to extract a data and then print. Print what? So print basically stemmer.stem, and here, so inside that I'm going to pass my I one by one. So Euron, as it is offer was, it was offers, right? There was S over here. And as you can see, it has removed S out of this one. 50, it has not done anything. Self-paced, I think that was a data ED. So it has removed ED, by the way, out of this self-paced. AI is fine. Data is fine. Science, it has removed E, I believe. Yeah, so it has removed basically E over here. Courses, so ES it has removed, and then from let, so let is there, us is there, is there, nor is there. So yeah, from some of this data, it is able to remove ES or maybe ED or maybe S, it is able to remove, and it is trying to convert my data set into a base word. Like I said, guys, so it is not going to give you all the time a correct result. So don't just rely on that particular part. This is how a stemmer is going to work. It's a very old library that you all will be able to find out. Okay. Now, so Potter stammer is done. Now I can try to use maybe a snowball stammer. So snowball stammer, maybe I can try to create an object. Again, same as like a Potter. Little bit different, right? Little bit different. Slightly, you can say more advanced than a Potter one, right? A Potter stammer, just a little bit. But again, so it is also going to give you some sort of a error. So snow, as a snow, I'm going to store it into a variable and okay, so for a snowball stammer, I think int missing requirement language. Language, is it? So en, let's suppose if I'm going to pass language, en is not supported. Okay, let me try in this way. So snowball stammer dot, I can try to call stem and let me pass some data. Let me pass maybe a learning over here. So missing one positional argument token. Okay. So maybe I'll have to go and check what is nomenclature of this snowball stammer. Ideally, it should work. So snow, it is not allowing me to create an object. It is telling me that it needs at least one parameter. I'm assuming that there is an English which it requires. But yeah, so I'll try to. Okay, so maybe I have to mention ENG, full form, not just ENG. So ENGLISH, English. Let's see. Okay, now it's working. So fine, we are able to create an object. Now I can try to call my object snow. So snow dot stem and then I can try to pass maybe a learning, 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 and yes, it is able to convert everything into a base word. Fine. So for learning it is working. So maybe I can try to call it for a entire data. So for I in, I think I had a variable called as data. Okay. So I in data. And then print what? So print basically snow dot stem and then here, so I can try to pass my I. Yep, I can try to pass my I. Now here, so Euron is fine, offers became offer 50, then cell paste, ED is removed, AI is same, data is same, E is same. Science, so E is removed, courses, so ES is removed and rest is same. So behavior of this snowball stammer and a Potter stammer looks same for me. So output wise both are same because I have a limited data. Maybe I can try this out with the different kind of a data. But like I said, it's little bit advanced, but again, you can't eliminate a possibility of getting a wrong output. You may receive a wrong output even in this situation, and there is a very high chance, right? There is a very high chance that you will be able to get some sort of a wrong result over here. Fine. So okay, now so stemming is one part. So stemming is going to convert your data into a base word, means it will try to remove ed, es, ing, all sort of things it is going to remove. I can try to use a Potter, I can try to use a snowball, or nowadays I can even try to use LLMs over here. There is something called as lemmatization, right? Lemmatization. So how lemmatization is different from a stemming? Let's try to understand it. Let me give you the example of this lemmatization, and then with the help of example, so let me try to explain you that how exactly lemmatization is going to work. So lemmatization, like I said, guys, so lemmatization is little bit different, not very different, but yeah, it's little bit different as compared to the stammer that we are using, whether it's a Potter stammer or whether it's a snowball stammer. So I'm going to take one data, and with the help of this data, I will try to explain you that how exactly lemmatizer is going to work for all of us. So lemmatizer is going to be a bit advanced as compared to the stammer, and even lemmatizer will try to convert everything into a base word, but it will also try to retain some of the meaning. For example, so if I'm going to pass maybe a better, so it is going to convert its base word into good, right? Good, better, best, right? So obviously for the better input, so obviously it should give me a good. If I'm going to give like a 8, ATE8, so its base word is going to be eat. So here in case of lemmatization, it is going to use some of the pre-trained model, which is already available inside a Spacie library, or it's already available inside the NLTK library. You can try to use some other model as well. You are not supposed to use always like a Spacey or NLTK as it's a old library, but yeah, so this is going to help you out to understand the concept. There are like hundreds of model which is available out there. You can try to use any of these models, but if you are trying to start ahead with something, then you should always start ahead with the Spacey or maybe NLTK. So with these two. So here I have already done the import of a Spacey. So let's do one thing. So spacey.load. So Spacey is one of the library. And here, so I'm going to load a model basically, which will help me out in terms of doing a lemmatization. So the model which has already been trained and it's already available inside the Spacey library. So I'm going to call English core underscore bev underscore sm. So this is one of the model which is available, and it is telling me that it's not available. So first of all, what I will do is, so I'll try to call Spacey dot download and download this model first of all, and then try to load this model, and hopefully it should work. So here, download it first as it's not available inside my system. Spacey download. I think it should work with respect to the download option. Let me check that. Okay, so it is telling me that there is no download function which is available. So maybe I can try downloading in a bit different manner. So I'll be using maybe just one Python -m Spacey and then download download en. So same model. So maybe in this way I can try downloading. So spacy Python -m and download this one. Let's see. So invalid syntax, maybe I can try to give a discrimination over here, and then it should work. Yeah, now it's working. So this is how it will be able to download. Now if I'm going to call a Spacey load this one, now this time it is not giving me an issue. Now this model I will be using, by the way, for doing a lemmatization, operation for all of you. So here, to do a lemmatization operation, so maybe I can try to prepare a sentence first. Maybe I can try to use my text data. So this was my text data, by the way. I can try to maybe pass like this particular data set itself. So here I can try to write like a for I in this text, or it should not be in this way. Otherwise it will go ahead with. So here I can try to use data which was available into this format. Yeah, I can try to use this particular data. So which is already available into a list format, into a word token format. So I can try to use this data. So I can try to write just like a stemming. So for I in data, so try to extract a data one by one for me. And then for all the I, return basically what? So return a lemmatization, LEMMA underscore. So return this one for this, all the I one by one. Let's see it is going to work or not. So here it is going to extract the data. That's completely fine. And for I.lemma, string object has no attribute called as lemma, LEMMA. It should work. Okay, so it looks like it is expecting data in a bit different manner. So it is not expecting this kind of a data. So where I'm directly passing a list. So here we have to perform a small operation, and then I hope I will be able to convert this data into a expected format. So there is something called as NLP. So NLP I'm going to call, and here I'm going to perform a join operation. So dot join. So join all the things which is available into my data list. So into my data list. And now this will become a data, right? This will become a data, and then I can try to pass this particular data. And yeah, so this time it is able to give me some sort of a output, fine? Some sort of output. Maybe I can try to write lemma underscore. So it is going to give me again sequence 0, expected string instance, Spacey token found. Let me check. my data. So my data has actually changed. Okay. And here, so if I'm going to check what is the type of my data, so obviously it should be available into a specie token docs. Yeah. So my data is available in this format. I have already done the conversion of the data. I can try to like keep it here, right? And then what I can do is I can try to call this operation on top of the data. So as you can see, so basically this one, so this lemmatization was trying to expect a data in a specie token docs format. And this is helping me out in terms of converting my data, which was a list, right? So which was a list of the words, word token. So it is helping me out in terms of converting this data into this particular format, in this compatible format, specie token docs.docs. Now, so all this operation, guys, you will be able to find out even on a specie official documentation. So where they are going to tell you that, okay, fine. So this is kind of an input it is expecting. So no need to remember anything. Even I don't remember anything. It's very tough to remember anything and everything, right? So that's the reason. So whenever I try to like a teach, or whenever I'm going to use it, I'll keep on doing experimentation, and I keep on exploring everything from its docs, or maybe I can try to take a help of AI, which is going to suggest me eventually things. So here, as you can see, after lemmatization, so I'm able to get some of the output. Yeah, some of the output. Now this lemmatization is going to happen from a pre-trained model, and it will be more accurate as compared to the previous one, right? So it is going to be more accurate as compared to the stemming, by the way, the stemming, the previous one that we have already discussed. So hope this basic operation with respect to a string is clear to all of us. So we have done a lot of things over here, guys. As you can see, we have like done a lot of experimentation in terms of like a cleaning of the data, in terms of tokenizing the data, in terms of removing the emojis or maybe a contraction. So lot of operations we have done, and all of these operations you are going to use it somewhere, maybe like today, tomorrow, or maybe sometime. So when you will try to build your own model, when you will be playing with the data, so at that point of a time, obviously everything is required. So with that, thank you so much everyone. Take care and see you again in my next lecture with a new concept, and I have attached assignment. So please make sure that you are going to do all the assignments, and then you can move ahead with the next chapter. Till then, take care. Bye bye. Okay, so welcome back to lecture once again, guys. Now in this lecture I'll be talking about classification. Now the intention is to show you whatever we have discussed so far, how we can use it, and how we can use it in a classical natural language processing approach, not in a modern way. So going forward, we have a lecture so where we are going to talk about a modern technique as well. So let me share my screen, and let's get started quickly. So here we have our data, as you can see, and inside my data, so I have a label and I have a messages. Now label wise, so this has been labeled as a spam ham, spam ham, spam ham, and these are the data which is available to me. Now what I have to do, so I have to basically read this data, I have to clean this data, I have to vectorize this data, I have to build a model, I have to test an accuracy of the model, and then I have to basically do some sort of a prediction. That's a whole idea, right? That's a whole idea behind this one. So here, let me create a file, and the algorithm which I'm going to use in this particular lecture is a logistic regression. I have already discussed about a logistic regression theoretically in my machine learning chapters, but here, so I'm trying to show you the use case of those algorithms directly in a practical manner, obviously. Logistics classification.ipynb. Okay, so this is a file I have created. Let me select my environment. So after selecting the environment, so let's start writing the code. So first of all, we have to import a couple of libraries, by the way, and once we are able to import a couple of libraries, then we can start doing a data processing end to end. Yeah. So first of all, let's try to import pandas as PD, and the same template I'm going to use it in my upcoming lectures as well. So same template. So whatever we are using here, same thing I will be reusing it in my upcoming lecture with respect to a different kind of a classification algorithm. So here import re regex basically, and then here I can try to import a string. So with respect to a string, if I do some sort of operation, and then from scikit-learn, so sklearn dot model selection. So here I'm going to use train and test split, so that I can split my data into a training data and into a testing data, the way we use it inside our machine learning algorithm. And then from sklearn dot feature extraction dot text. So we are going to import TF-IDF, not a transformer. So TF-IDF vectorizer we are going to import. You can try to use a word to vector, you can try to use a TF-IDF, you can try to use a bag of word, your wish. Yeah, your wish. So I'm going to use one of these because all of these things I have already discussed in my previous section. Now here, so from sklearn dot linear model, so I'm going to import a logistic regression model over here. Fine. In my upcoming chapter, so I'm going to use a different kind of a model. So for example, a support vector machine I can try to use. I can try to use a naive Bayes over here. I can try to use a decision tree classifier over here. I can try to use a random forest for a classification. I can try to use XGBoost for the classification. So there are tons of classification algorithm you will be able to find out, but I'm just going to use a basic one, and in my upcoming section, so I'll try to show you a couple of more. Now here for a evaluation, so I can try to like import sklearn matrices and import classification report and import confusion matrices. Okay, and obviously I would like to save my model, so I'm going to import a job lib. Now these are the import you have to do, and if you are going to get any kind of a issue with respect to import, yeah, so what you have to do, you have to basically do a pip install. That's it. You have to do basically a pip install. So for scikit-learn, let's suppose if it is giving me an issue, so maybe I can go to Google and try to search PyPy. So PyPy sklearn, and it is going to give me like what I need to install. So I have to install this one. So pip install sklearn I can try to do over here. Execute. Okay, so looks like it is able to do the installation. Let me restart my kernel and execute once again. Now this time there is no issue at all, right? So I'm good with the imports. All the imports is done. Now moving ahead. So once we are able to do the import, we have to read this particular data. Yeah, this particular data I have to read. So here I can try to use a pandas library, and I can write read CSV, and here so I can try to give my file name, so whatever file name that we have, and as we all know that it is going to return me a data frame. Fine. So data frame, so this is my data, so where I have a label and then I have a messages. So we have a label as spam ham, spam ham, spam ham, and then we have our respective messages. Okay, now so inside my message or inside my data, you will be able to find out lot of unnecessary information. So maybe I have a number somewhere, as you can see, right, which is not having any kind of an impact on spam or ham. Maybe I have a punctuation marks over here, dot, comma, all these things. Again, it is not having any kind of a significance on whether data is a spam data or whether data is a not a spam data or ham data, right? Or we have a white space in between. So I have to take care of all of these things. So maybe I can try to write a function, so which is going to clean my data. So here clean underscore text I can try to write, and then I can try to pass a text over here, and one by one I can try to clean the data. So here whatever text you are going to pass inside this function, so I would like to convert all of this text into a lower format, right? So into a lower case. So this is one. Now once I will be able to convert this data into a lower case, simply like a normalization of the data, then I would like to remove all the numbers. So maybe I can try to call a regex, and then I can try to pass a pattern for a regex, by the way. So pattern for removing a regex is this one. So it is going to remove all the numbers with a blank, whatever text data that you are going to pass, and it is going to give me return as a text information. Now, so the next thing is, so I would like to like remove all the punctuation. So to remove the punctuation, regex, you don't have to remember any of these things, don't worry about it. Yeah, so to remove the punctuation, so I am just trying to use this one. So escape string punctuation, so just try to remove all the punctuation. So inside string punctuation, you will be able to find out all the punctuations, everything you will be able to find out inside the string punctuation. So I'm removing string punctuation, by the way, and then I'm going to normalize all the white space. So wherever there will be a white space, right, wherever there will be white space, I'm trying to strip it. Fine. And then finally, it is going to return me the textual information. So this is going to take a text data, and then it is going to perform all this 4 operation, and finally you will be able to get your data. Now this function is a external function which I have written. Yeah. Now I have to apply this function on top of this data, which is available in a form of data frame. So how I will be able to apply this particular one on top of the data frame? So let me talk about that. So here data frame, and I can try to extract a column. So column is basically a message column in which I have a raw data, right? I have a raw data, and then I can try to call dot apply, APPLY, apply. So as we know that it can consider any kind of a external function. So here I can try to call my clean text function, and it is going to apply. Now if I'm going to execute it, so you will be able to find out that it is returning me the clean data. So whatever like a operation that I have written inside this operation, inside this clean text, so it is trying to clean. It has cleaned all the like a punctuation. It has converted all the data into a lower cases, and it is going to return me. Now what I can do, right? So what I can do, so I can try to store this output into another column called as CLEANED, clean underscore message. So inside this, I'm going to store it so that permanently I will be able to retain it. So data frame, now if I'm going to call, so it has created another column called as cleaned messages, and it has cleans, and you can see the differences. So everything is available into a lower cases. Previously free F was capital. Now F is like a small. It is able to remove this question mark. It is able to remove this comma from here. So whatever operation which I have done, so yes, it is able to perform it. And finally I have a column, so where I have a clean messages. Okay, fine. So I'm able to clean the data. This is again a crucial part. And as per your data, so you have to write a different kind of a operation. Fine. Now I have a label over here, and label is available as a spam ham in this way. Now, what I wanted to do is that I would like to give a numerical labeling. So for a spam, let's suppose 1, and for ham, I would like to give a 0. So this is something which I would like to do, and I would like to create a new column. So let's do it. Yeah. So data frame, and let's try to take a label. Now, so I'm going to call a mapping over here, and inside this mapping, so I'm going to write that wherever you are able to find out ham, right? Wherever you are able to find out ham, so keep it as 0, and wherever you are able to find out spam, so just try to label it as a 1. Okay, just try to label it as a 1, and then create a new column. Called as label label underscore name, and store this information there. So fine. Now if I'm going to show you my data frame, so it has created one column called as label name, and wherever we had a spam, so it has mapped with 1. Wherever we have a ham, so it has mapped with 0. So again, we are able to create a required data, right? Create a required data. Now, so as we can see that our X data, which is a cleaned message, so it is available in a form of a text. And I can't provide this text directly inside my algorithm. That's a problem, right? I can't provide this text inside the algorithm. So what I can do? So I have to convert this entire things into a numerical representation. Now to do that, I can try to use a bag of word. I can try to use maybe a TF-IDF. I can try to use maybe a word to vector. I can try to use even a URI LLM. And by using all of these, only one thing I will be able to achieve, that I will be able to convert my data into a vector space or into a numerical format, which is good data for passing into my model. I can't pass this textual information directly inside my model. So here I will be using a basic vectorizer, which is a TF-IDF, which I have already shown you in my previous lecture as well. So here just try to call TF-IDF vectorizer and try to store it into a variable vectorizer. Okay. And then what you have to do is that try to call this vectorizer dot fit transform. Yeah, fit transform. And then what kind of a data you have to fit? So data frame, and here, so cleaned message. So this is the data that you have to pass, and this is going to give me my X data. Yeah, this is going to give me my X data. Now if I'll show you my X data, so X data is having 10 cross 41. So 10 rows and 41 columns in which it has created the data. So if I would like to see a data, I can see the data as well. So x dot and then I can try to call to array. Yeah, so to array, and this is the data I'm able to see. So for every, so this is one line, this is the second line, lots of sparse we have over here, lot of zeros we have over here, but that's completely fine. So this is our data which it is able to create. So my x is ready, right? What is my y? So my y is nothing but data frame and then label name. So this is my y. If I would like to show you y, so this is my y, by the way. So I have my x data, I have my y data. Now I can try to use this x data and y data for a training purposes, right? So for a training purposes. So to do that, I have to call a train and test a split. And then here I can try to pass my x data, I can try to pass my y data, and then I can try to give my test size. So let's suppose 0.2 means 80% data for training, 20% data for a testing purposes. And maybe I can try to call a random state is equals to 42. Yeah. So this is going to return what? So x train, comma, x test, comma, y train, comma, y test. Simple, right? So we have done this kind of things not just one time, but a multiple time, right? So multiple time we have done the same kind of operation inside our machine learning algorithm. So this is my train and test data. Now what I can do, I can call my model. Logistic regression is the model which I'm going to use. So this is going to my model. Okay. Now I can try to call model dot fit basically. So fit and fit wise. So I can try to pass my x train, comma, y train. Yeah. So now it is going to build a model for me. Simple, with all of these parameters. If I would like to play with any of this parameter, I can try to play with any of this parameter. With any of this parameter, I can try to play around. As simple as that. I can try to change this value, and then based on that, I can try to build my model. But yeah, as of now, I have already built the model. That's completely fine, right? So I am able to build the model. Now, if I have to do a prediction with respect to model, so I can try to call model dot predict, and then here, so I can try to pass my x test. And it is able to do the prediction. So x test, I have only two data, right, inside my x test, and is giving me 1 and 0. So 1 for the first data from a testing set, and then a 0 from the second data. Maybe I can try to check that how accurate my model is. Yeah. So how accurate my model is. So let me save this one into y prediction. Okay, now here, so if I have to test my model, so maybe I can call a classification report, and here I can try to pass my y test and then y prediction, so that it will be able to give me the classification report. Okay, so let me print this classification report in a formatted way. So maybe I can try to call print over here, and then this is the report which I'm able to get. Yeah, which I'm able to get. So it's like 100% accurate, it seems, right? It's 100% accuracy that I'm able to achieve. Maybe I can try to call a confusion matrices, and again I'm going to pass the same information, y test versus y pred, and yeah, so it's 100% accurate, like a model that we are able to build. The reason was very simple. Data was very simple, plain and small, and plus we have used, I believe, a corrector vectorizer with respect to the data. This data was not at all complex, and the task that we are trying to perform is again not a complex one. The task is also a very simple one, right? Very simple one. So 100% accurate model we are able to build, and again, I don't think that we are doing this logistic regression classification for the very first time. We have done that multiple time in the past, right? Multiple times means literally a multiple times in the past. So I'm not assuming that any one of us is new with respect to a logistic. Yeah, it's a very old algorithm for all of us. We are studying this algorithm since our machine learning chapter, since our very first day of the machine learning chapter. So we all are studying this particular algorithm. Now, so I would like to save my model as a physical file. So how I can do that? So joblib.dump I can try to call, and then I can try to save my model. So how I can try to save my model? So call the model object that you have created because this is the model, right? This is the model object that we have created, and I can try to save it with my own file name. So I can try to call logistics spam dot pickle file, pkl, yeah, sorry, pkl, pickle file. So it is going to save your model. Yeah, it is going to save your model. Now if you will come over here, you will be able to find out your pickle file, your binary file. Yeah, but here, so you're not supposed to just save the model, you are supposed to even save your vectorizer, because whenever you will try to do a prediction with the unknown sentences, so you have to have like this particular vectorizer, then only you will be able to vectorize a data, and then only you will be able to pass a data. So you have to save your vectorizer as well. So let's save a vectorizer. So joblib dot dump I can try to call, and then here, so I can try to call my vectorizer, by the way. So vectorizer, and then I can try to save it as a TF-IDF underscore spam dot pkl, pickle. So now it will be able to even save your vectorizer. Yeah, so I'm able to save my model, I'm able to save my vectorizer. Now if I have to do a prediction, so how I will be able to do a prediction from a physical model, right? From a physical model, how I will be able to do a prediction? So here again you have to use a joblib and read the model. Yeah, joblib and read the model. So here load model classification is equals to joblib dot load, and which model I have to load? So this model I have to load basically. So just try to pass this model, it will be able to read the model and keep it here. I'm talking about the physical model, right? And similarly, so load a model for the vectorization, because that is also important, vectorization, and which model you will end up loading. So basically this model you will end up loading, the model that you have saved in a physical space. Now, so with respect to this model, if I have to do some sort of a classification, how I can do it? For example, so let's suppose I have a sample text data. Yeah, someone has given me this sample text data, and inside this data, there is an information mentioned that congratulations, you won a free trip. So this is one data. Then there is another data. Let's meet at 5 p.m. IST for discussion. So this is the data set that we have, these two data set, which is an unknown data set, which is not a part of my training or testing data, right? So this is an unknown data. So how I will be able to do a prediction for this particular data? So first of all, I have to call a data cleaning, because this is what I have done, right? So I have to do a data cleaning. So here I can try to go through a loop for I in a sample text, one by one read the data, and then try to call a clean text and try to provide a I over here. So this is going to return me a list of the clean data, because this is what I have done, right? So this is going to return me the clean data, sample underscore CLEANED, clean data. Yeah. So this is going to return me the clean data. You can go ahead and you can try to check. We have just done a comprehension operation. So it has cleaned the data. It had normalized the data into a lowercase, and then all the punctuation marks, everything it has removed. Whatever data was unnecessary, all this numeric value it has removed. So yeah, now it is able to clean it. Now, once I have a clean data, so I can try to do a vectorization. So here I can try to load a model vectorizer, and then I can try to call transform. So that, and I can try to provide the clean data over here. Now this is going to give you sample vectorized data, right? Sample vectorized data means this data is available into a numerical format. If I'm going to call to array, you will be able to see the data. So I had two data. So one is this and one is this after vectorization. So I'm able to get this data after the vectorization. Now, once I'm able to get this data after the vectorization, I can call the model and do the prediction. So here, physical model. So here, load model classification was my physical model. So call it and then call the prediction. Simple, right? And then just try to pass this sample vector data, sample vector data, it is going to give you the output. So 1 and 0. Yeah. So for like very first data, which was congratulations, you won a free trip, it is telling me that it's a spam. Spam means 1, right? And let's meet at this PM IST for a discussion. So this is basically a ham. So that's the reason it's giving me 0. And I believe it's a correct prediction that it is able to give it to me. You can try to, convert this 1 and 0 as a ham and spam. That is like a possible, right? That is possible. But yeah, so this is what we are able to achieve. And yeah, so successfully we are able to build a model. We are able to use a vectorization. We are able to use a data cleanup. We are able to even save a model, vectorizer model, as well as we are able to save our classification model as a physical file. All these things has been done. So hope all of you have liked it. All of you are able to understand it. And with that, thank you so much, everyone. Take care and see you again in my next upcoming lecture. Okay, so welcome back once again, guys. Now in this lecture, I'll be talking about multi-class classification for an NLP task. So here we are going to consider a textual information, so which is based out of a news, a different kind of a news into a different category, maybe from a tech category, a sports category, or maybe a politics, maybe a entertainment, all sort of a categories we are going to consider, and then we are going to build a model. And obviously I'm going to use a vectorizer, so which is eventually going to transform my data set into a numerical space. So let me show you this. And again, this is a part of your classical NLP. I'm not using a new approach. I'm using just a old man approach over here. For a new approach, we have a class, so don't worry about that. But I believe we all should know about our old approach as well. So here is my data. As you can see, we have multiple categories, and we have a data set over here, and we have to build a model. And obviously we have to build a multi-class classification model for this one, because we don't have just a binary class, we have a multiple class over here. Now algorithm wise, I'm going to use a naive bias over here. I can try to use even a logistic regression, that's completely fine. But yeah, so I have decided to use a multinomial naive bias algorithm over here. So let me create a file, and naive bias news categorization.ipynb. Yeah, so this is something which I am going to consider. And now, so let's try to do an import. So this is not going to be very different. So I think we have already done this part in my previous lecture. So when I was talking about a logistic, I'm going to make a little bit of changes, yeah, in terms of an import, as you can see. So here, instead of importing maybe a logistic, I'm just trying to import a multinomial naive bias. Apart from that, so everything is exactly same, not just this one. So here I have to read a data, and after that I have to perform a clean text operation. I will be using a exact same function from my logistic. Simple, right? Now let's read a data. So data is nothing but a pandas dot data frame, and here so we have news data dot csv. Now if I'm going to show you data frame constructor not properly called, okay. So news data dot csv, and index ensure index, there is some problem it seems with my data. Not an issue, I'll fix it. So again, let's call it pandas dot, my bad, read csv, right? We are reading a csv. Read csv, and here, so obviously now, so if I'm going to show you my data frame, so there was a minor mistake, by the way, from my end. Now here, so we are trying to read a data frame, as you can see, and after reading a data frame, so we are going to perform all sort of operation. For example, data cleaning operation I'm going to perform. Yeah, data cleaning operation. So here for data cleaning operation, I can try to call data frame, and then what is data? So we have a text data. I'm going to call apply function, APPLY, apply function, and then I'm going to pass a clean text function over here, and whatever it is going to return, so I'm going to store it inside a column called as clean underscore text column. Yeah, okay. So let's store it. Now if I'll go and show you a data frame, so there is a new column it has created, CLEA, CL. Okay, so ANAD. Okay, so clean text. I can delete this column. That's completely fine. So maybe I can try to call delete data frame and then this column name. So sorry, so I can try to call drop over here. So data frame dot drop drop and drop what? So drop basically this column which I have created unnecessarily. So clean text column, drop it, and across axis axis is equals to 1. Fine, and then store it as a data frame. So now if I'll show you, so that column is gone. That column is gone. I have just created that column unnecessarily by mistake. So I have just deleted that. Now once I'm able to do this, now what I have to do? So I have to prepare my X and I have to prepare my Y. For my X data, this clean data, so I have to convert this data into a vector space, right? So TF-IDF vectorizer I can try to call, very simple. So TF-IDF vectorizer and vectorizer. So I can try to call vectorizer dot fit transform and I can try to pass my data over here. So data wise clean text data column I'm going to provide, it is going to give me my X, simple, right? So you can try to even check. So you can try to call X dot to array and you will be able to see the data. So this is my clean text data. So it's 100 records. That's the reason it's showing you dot dot dot. So we are able to see the clean data and we are able to convert X into a clean data. Now we have to create our Y as well. And if I'll talk about a Y, so we have a multiple categories, not just one single categories. So maybe we can try to give a label 0, 1, 2, 3 in this way, or in an automated way, we can try to call even a label encoder. So here I can try to call sklearn dot preprocessing and import. I can import a label encoder. Now this is going to work for me and let me call this label encoder and this is going to help me out in terms of labeling the entire categories. So label encoder dot fit transform I can try to call and then I can try to provide my data frame categories. Yeah, so now this is going to return the label automatically. So I can do it in a manual way, that the way I have done that in my previous lecture, so where I was doing a mapping. But here, so we have a multiple categories and I have to convert those categories into a numerical information. So I'm just trying to call it directly as a label encoder and this is right. So this is technically going to be my Y. Fine. So let's try to store it in some of the column. So here data frame and category encoded. In this column, I'm going to store it. So now if I'll show you my data frame, so I have another column called as category encoded and here we have a equivalent numerical representation of the categories. Simple, right? Now this is going to my Y. So my Y is ready, my X is ready, right? So category encoded, my Y is ready and my X is ready. Both is ready now. Now, if both of this is ready, I can try to call a train and test split. And then I can try to provide my X comma Y over here. I can try to give a test size. So maybe 0.2, 20% for testing, 80% for the training. And then a random state is equals to 42. I can try to define. Now this is going to return me what? X train, comma, X test, comma, Y train, comma, Y test. So this is something it is going to return, right? Now I'll be using this one for a training purpose. So I have to use a model called as naive Bayes. Again, so naive Bayes is one of the algorithm by which you will be able to do a multi-class classification. So here I have to call a multinomial naive Bayes algorithm and let me create an object for that. So model, and then here I can try to call model dot fit, right? Fit, and I can try to just give X train and Y train over here, and it will be able to create the model. And whatever parameter that I would like to override, I can override it. Simple, right? So my model creation is done. Now, once my model creation is done, what I can do, I can try to test this model accuracy, right? I can try to test this model accuracy over here. So I can try to call model dot predict predict, and here, so I can try to provide my X test, so that X test I can try to provide, and this is going to give me the prediction. So Y underscore pred, it is going to give it to me. So I have a Y prediction and I have a Y test basically, right? So I can try to do the comparison. So here print, and print what? Confusion matrices, and here I can try to provide Y test comma Y pred, right? So this is the confusion matrices, and it looks like that there is no like a numbers on this right hand side or left hand side of the matrices. Everything is available on a diagonal. So it looks like it is able to do, or it is able to build a model which is 100% accurate. Now I can try to even like draw the classification report. So classification report, and yeah, so it is giving me for all the classes, it is 1 1 1. So class 0 1 2 3 4, it is 1 1 1 1 1. So accuracy is equals to 1. So it's a 100% correct model that we are able to build, and that too with the hundreds of records, right? That too with the hundreds of records, we are able to build a 100% accurate model. That's amazing, right? That's amazing, pretty much, I would say. Okay. So now we can try to save this model as a physical file the way we have done that in my past. We can try to save our vectorizer as a physical file the way I have done that in a past. So I'm leaving that thing up to you. In my logistic regression, already I have shown you that how to save your vectorizer, how to save your model as a pickle file, and then how to load it and how to do a prediction on top of those physical file, right? Our model looks pretty much good, by the way. So with that, thank you so much everyone. We are able to do a multi-class classification with the help of naive Bayes algorithm. So with that, thank you so much. Take care and see you again in my next chapter. Okay, so welcome back to the lecture once again, guys. Now in this lecture, again, I'm going to show you a text classification. So where I'm going to use a vectorization. My model is going to be different. So this time I'm going to use a support vector machine, and even inside that, so there is something called as SVC. There is something called as linear SVC. So I'll be using a linear SVC over here. I'll give you a reason as well for that. I can use a SVC. That's completely fine. It is going to give me like a more option for a different kind of a kernel. If you remember SVC, right? If you remember SVC. And if you don't, in that case, please try to follow along my machine learning lectures. You will be able to understand it. So here, let me like create a new file. So SVC underscore TF-IDF. Sorry, I should give a name as .ipynb. So .ipynb. Okay. Now here, let me select the kernel. Okay, that's great. Now, so I'm going to do some sort of an import over here. And as you can see, I'm trying to import a linear SVC, right? Linear SVC over here. Now, so you can try to import a SVC. That's completely fine. You can try to import a linear SVC. You will be fine. In case of linear SVC, it just support a linear separator, means a linear kernel. If I'm going to import a SVC, so in that case, it supports a RBF, it supports a polynomial, it supports a sigmoid. Simple, right? So that's major differences you will be able to find out between linear SVC and SVC. And obviously linear SVC is a simple one, so it will be way faster as compared to the SVC. But yeah, anything you can try to use, that's not an issue at all. So here we are going to consider a raw data. So let me do the import, and import is done. So we are trying to like take a data. So I have my X data and I have a Y data. So this is the label and this is the feature that I have. Okay, now consider it. And then what we are going to do, so we are going to maybe like, do this entire things in a little bit different way. So I'm going to use a make pipeline option. And inside a pipeline, so I'm going to call a TF-IDF vectorizer, and I'm going to call basically linear SVC. So linear SVC that I have done as an import. So automatically it will be able to handle everything. In my previous example, so I was not doing the same, right? I was not using a pipeline. So I was trying to do a TF-IDF vectorization separately. I was trying to call the model in a separate direction. But here what I'm trying to do, so I'm just trying to call both of this. I don't want to see the data. So what will be the output of the TF-IDF vectorizer and any other things, right? So simple, make a pipeline and then call the model over here, right? Model over here. So now model is done. Yeah, model is done. Now I can try to just call model.fit over here, and after calling model.fit, so I can try to pass my X data and I can try to pass my Y data. X is not defined. I think it's a capital X. Okay, so cool. I'm going to pass my X. Yeah, so X and fit. Everything is done now. Yeah, everything is done now. So pipeline is able to take care of each and everything automatically. I don't have to worry anything about it. So this is the simplest way. This is how a scikit-learn had designed the entire library for you, and you don't have to worry about anything, right? So TF-IDF vectorizer or maybe a model implementation, and you can try to call it with any other model. Simple, right? Any other model, and in a pipeline, so just try to put all these things. Bingo, work done. So instead of writing a multiple line of a code, just use a pipeline. Very simple. I'm just trying to show you the flavor, by the way. Yeah, I'm just trying to show you the flavor. Now I can call model.predict, and here I can try to pass my data. So maybe I can try to pass something like can we meet today, 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 and it is telling me that yeah, it's a ham, by the way, right? Can you meet today? So it's telling me ham. I have an offer for you. I have offer for you. Now it is telling me ham. Maybe I can try to pass some of the data. I have offer for you, which will help you to win money. Now it became a spam. Yeah. So it looks like it is able to do a very amazing and accurate prediction, and my implementation is also sorted, right? It's a very, very simple implementation that I have done. Very simple implementation with no fancy stuff, and it is able to handle each and everything for me. So yeah, not just that. So yeah, we are able to do a prediction. That's a completely fine. Let me show you even a fine tuning, right? So fine tuning. So here you can do a parameter fine tuning for a TF-IDF, and you can try to even do a fine tuning for a linear SVC that you are trying to use. So how we can do a fine tuning? Let me give you a flavor of that. So I can try to call from sklearn, sorry, not skimage, sklearn dot model selection. I can try to import a grid search CV. So grid search CV is going to help me out in terms of doing a fine tuning of the model. So here make pipeline, and in my pipeline, so I have what? I have TF-IDF vectorizer, same thing as above, nothing different, and linear SVC I have. So this is the pipeline, let's suppose PIPLINE, pipeline. I have just named it as a pipeline. Okay, fine. Now for this pipeline, so basically I have to basically do some sort of fine tuning for some of the parameter. Yeah, for some of the parameters. So maybe for a TF-IDF, I would like to do some sort of experimentation with the Engram. Yeah, Engram, or with a linear SVC. So again, I would like to play ahead with some of the parameter which is available inside a linear SVC. So let's see how we can. Okay, so if we go above, so we have a multiple parameter into a linear SVC. As we can see, we have a multiple parameter even inside a TF-IDF vectorizer, right? So we can try to maybe take some of this parameter, and we can try to check that, okay, so which one is working well for me. So here to do that, we can try to create a grid for this one. Parameter grid means a parameter, multiple parameter option. Yeah, multiple parameter option. So let's create it. So here for TF-IDF vectorizer, maybe we can try to TF-IDF vectorizer Engram. I'm going to write it in this way. Engram range is basically take it 1 comma 1, so means unigram, and then here, so try to take it unigram and bigram. Fine. So this is for a TF-IDF. It will try to test it, and then here, so for a linear SVC, so I'm going to like test it with the multiple regression parameter. So regression parameter here, it could be 0.1 I can give, it can be 1, and it can test with 10. Yeah, so these are the parameter by which with which it is going to test it. So there is some mistake, linear SVC. Let me execute invalid comma comma. Oh, I have given this one over here. That was a problem. Fine. So this is the parameter grid which I have created over here. And then now let's try to call a grid search CV. Let's pass the pipeline for which we are doing a fine tuning, and parameter grid is equals to basically parameter grid, and then cross full validation is equals to 3. Yeah, so that you can divide the data into like a 3 part. So I am just trying to train or tune this one as well as this one. So from here I'm trying to tune C, and from here, so I'm trying to tune this Engram range. Simple, right? I can try to tune other parameter as well, but as of now I'm just trying to tune this much. Now here, so maybe I can try to save it as a grid, right? Grid, and then grid dot, I can try to call fit, and I can try to pass my X data, which was capital X, I believe, and then I can try to pass my Y data. So here, fine, this name is an issue. Let me make it correct. It should be double underscore, and it should be double underscore to access this parameter, because this is the class name and then this is the parameter name, right? So now you will be able to, yeah, so now it is able to basically tune this one as well as it is able to tune this one. So it is able to test based on both of this tuning. Now what it is trying to do internally, let me show you that part. So internally, let me call a markdown over here. So internally, it is trying to take this combination. So Engram range 11, C 0.1, 11, C1, 11, C10. Then 12, 0.1, 12, C1, 12, C10. So this is basically a combination. It is trying to test one by one, one by one, one by one. Simple, right? So this is something that it is trying to test one by one. And here you can see a red mark. Red mark means it is trying to tune this particular parameter with that combination. Now, if I would like to know that which combination is behaving best, right? Which combination is behaving best? So let's try to take out a best parameter. So to take out the best parameter, I have to call a grid over here, grid grid, and the grid dot best underscore param underscore params, I believe, yeah, underscore. So from a grid, it has test, sorry, I'm trying to call it as a markdown. Convert that as a code. Grid, right? Let me check the spelling by the way, guys. Yeah, so grid, this is what I have done with a fit. Grid dot best params, this one. So best params for C is basically 0.1, and for TF-IDF Engram, so the best parameter is 1, 2. This is the best combination that you should take. So here even we are able to see that how we can do a parameter fine tuning. Likewise, you can try to do a parameter fine tuning for anything and everything. Just have to make sure that this is the class name. Simple Python concept. This is the class name and this variable is private. So class name and then underscore private we are trying to call, and you can try to pass any combination and it will try to create a permutation combination with respect to that combination. Simple, right? Simple. And eventually it is going to give you the best parameter. Now I can try to use that best parameter for what? So I can try to use that best parameter for my next model building. As simple as that, and every detail you all will be able to find out here itself. So fine guys, with that, hope all of you are able to learn a lot, all of you are able to understand a lot, and see you again in my next chapter. So with that, thank you so much everyone. Okay, so welcome back to lecture once again guys. Now in this lecture I'll be talking about vectorization technique, and one of that vectorization technique is called as bag of word, and that is something which I'm going to discuss with all of you. Now, what is the meaning of this vectorization? So vectorization is nothing but converting your textual information into a numerical format. Because at the end of the day, machine will not be able to understand any of your textual information. So it is going to understand formula, it is going to understand a mathematical relation. And so we are supposed to pass a data even in terms of our numeric values, and this is where this vectorization comes into a picture, and bag of word is one of the technique. There are variety of the technique that you will be able to find out, but yeah, so bag of word is one of the technique by which you will be able to convert your data into a vector. So let me share my screen, and let's start talking about a bag of word, that how it is going to convert your data into a numerical representation. It's very easy to understand, by the way, not at all tough. So let me take an example. So let me open up my Scribble ink, and here, yeah. So here, if I'm going to talk about vectorization, so in a very simple way, let's suppose I have a data which is given to me. So let's suppose I have a document 1 which is given to me, document 2 is given to me, and document 3 is given to me. Fine. I'm going to take a very simple example. So here document 1, so data 1 you can say, in other word, so it's written over here as I love NLP. In document 2 it's written over here that NLP is fun. Yeah. And document 3, so we have a data called as I love coding in NLP. Yeah. So these are the 3 documents which is given to me. Now, if I have to convert this entire data, document 1, document 2, and document 3 into a numerical representation, so how I will be able to convert it? That's a very first question. Yeah, that's a very first question. And the technique which I'm going to use over here is called as BOW. So bag of word. It's one of the oldest technique, or one of the initial technique you all will be able to find out. And here, so this bag of word which I'm going to talk about, so this like vector representation of this bag of word never consider a grammar or even a ordering of the word, that which one will come after which one. So it always care about the frequency of the data. It always cares about the frequency of the data. So let's do it. So first of all, let's suppose we have these 3 documents. So we will try to find out a unique data or unique word, I would say. So unique, unique value or unique data we are going to find out. So here I can write unique data wise. So I is a unique. Then we have love over here. We have NLP as a unique. Then we have is as unique. We have fun as a unique data, and I have love, then coding is unique, in is unique. So these are the data that we have as a unique one, right? So these are the unique data that we have. Now these data set is going to behave as a column value, right? These data set is going to behave as a column value. How? Let me show you that part. So for example, if I'm going to convert this document 1, right, so into its numerical representation. So in document 1, as we can see, we have I, we have love, we have NLP. So I is 1, love is 1, NLP is 1, and rest is going to be 0, 0, 0. Now, so this is representing a document 1, right? This is representing a document 1. Now, So if I'll have to convert my document 2 into a vector representation, so this is one of the vector. This is a vector for what? A document 1 I'm able to convert. So wherever we have a data, mark it as 1, and then rest of the data which is not available, mark it as a 0. Simple, based on the unique data. So unique data from the entire document, whatever document that is given to you. Now we have a document 2 over here, as you can see. So in document 2, NLP is fun. So NLP 1 is fun. The rest of the value is going to be 0, 0, 0, 0. Simple. And now if I'm going to talk about a document 3, so again, same thing is going to happen. So I love coding in NLP. So wherever we have like a I 1, love 1, we have NLP 1, we don't have is, we don't have this one, we have coding, and we have in. So this is basically a data which is going to represent my document 3. So in this way, I'm able to convert all of my data into its numerical representation. And the technique which I have used over here is called as bag of the word. Yeah, bag of the word over here. So which is going to consider, by the way, the frequency of the data over here. Yeah, frequency of the data. So how many times like data is going to occur. As we can see, I is occurring only one time. So I have mentioned 1 over here. Love is occurring only one time, and like NLP is occurring only one time. Is occurring 0 time. Fun is occurring 0 time. Coding is occurring 0 time. In is occurring 0 time in the document 1. So whatever times it is going to occur, so we are going to write down as a frequency. Simple as that. So if it is going to occur 2 times, so I'll try to mention 2. If it is going to occur n times, so I will try to mention n. Very simple, right? So based on the frequency of the data, so we are trying to basically create our entire vector, and this vector I will be using as an input. So if I'm trying to solve some sort of a problem with respect to this data, so I will be using this one. Simple. So hope we all are able to understand theoretically that what is a meaning of a vectorization, by the way, and in case of bag of word, so what we are trying to do with respect to the vectorization. Now, so like I said, it's one of the oldest technique, and it is never going to consider the grammar and a word order. It just care about a word frequency, nothing else at all, nothing else. Yeah. So with that, thank you so much everyone. Take care and see you again in my next lecture. Okay guys, so let me show you everything that I have shown you in my previous lecture in a practical manner. So let me share my screen and then let's start talking about it. So here what I'm going to do is that I'm going to call one of the library from a sklearn, which is called as counter vectorizer, and which is going to help me out eventually in terms of performing a bag of word operation. So here I can write from sklearn. So from sklearn dot feature extraction and dot text. So dot text. So basically import count vectorizer. Yeah, and then we can try to import pandas as PD. Fine. So this is the library import that we have to do. Now once we are able to import the library, let's try to prepare our data. Fine. So here data wise we had I love NLP, right? Then we had NLP is fun. So this is the another data that we had. And then we had basically I love coding in NLP, right? So this was data which I had considered, as you can see in document 1, document 2, document 3, and same data I have considered even over here, right? Very simple. Now, so we have this count vectorizer. So what we can do, we can try to create a variable of this count vectorizer. Let's suppose I'm calling it as a vector, by the way. Yeah. So vec, and then I can try to call vec dot fit transform, and I can try to pass my entire list. So list is having a multiple data. Yeah. So it is going to do something. So it is going to convert basically 3 cross 6. So 3 rows and 6 column matrices. It is going to create for me. It has already created for me. Just a matter of time that I have to check the data. So let me store it into a x, and then x dot if I'm going to call to array, so that I will be able to see my data. So here is my vector for our document 1, document 2, and document 3, which I'm able to get. Yeah, which I'm able to get. Now, how internally it is trying to do it, what is the column name, what is the feature name. So all these things, obviously, I would like to know. Yeah. So obviously, I would like to know. So here this vec dot you can try to call get feature name out, and it is going to give you all the feature name that it has considered. Yeah. So it has considered coding fun in is love NLP. So these are the unique word which we had. So yes, it has considered already. Yeah, it has already considered it. You must be able to observe that it has not considered I. So by default, this count vectorizer, what it does is that if the length of the data is more than 2 or equal to 2 or more than 2, then only it is going to consider. If it is lesser than 2 means 1, it is not going to consider. That's the reason, so it is chopping off. But yeah, you can try to forcefully consider that part as well. But yeah, it is trying to just remove those words as a stop words automatically. So if length is equal to 1, more than 1, obviously it is going to consider. That's the reason. So I you will not be able to find out. But like I said, so you can try to pass regex over here, and with the help of that, you will be able to even consider that particular part, which I will show you. So don't worry. Yeah, which I will show you. So it is going to consider even I part for that. So here these are the features. So if here TURES features, or you can say a column name, right? We have. We can try to call maybe a pandas dot data frame, and we can try to convert this entire things into a tabular format so that I will be able to see it. I will be able to visualize it. So columns is equals to features. Yeah. So this is the things that you will be able to find out. So love NLP. So first sentence was I love NLP. So anyhow I it is not considering because the length is lesser than 2. So I love NLP. So love 1 NLP 1. Then NLP is a fun. This was the second sentence. So NLP is and fun. So wherever we had a data, so yes, it is trying to mark it as a 1 1. And I love coding in NLP. So yes, love coding in NLP. So everything is available as a 1. Very simple, right? Very simple. So everything is available to me. Now let me do one thing. So here I'll try to increase frequency. I love NLP, NLP, NLP. Yeah. So if I'm going to do so, so here you will be able to find out that if NLP is occurring 3 times, it is trying to call it 3 times, as simple as that. So that's the reason. So bag of word is called as a frequency based vectorization technique. So it always try to count the number of occurrence of the data, and then eventually it is trying to give a number. And this is the vector which is representing a very first document sentence. You can say this is a second one, and this is a representation for the third one. Simple, right? Simple. Now, so let's suppose I have to even consider I, right? So even I have to consider I. So what you can do is that you have to just make one small changes into this counter vectorizer. So just try to mention that token, or you can say like a token pattern, which it is going to consider should accommodate even a single word. Yeah. So this is how like you can try to write a regex, and you will be able to set that up. Now when you are going to do that, it is going to consider now even I. Yeah, it is going to consider now even a I part, as you can see. So very simple, not at all a difficult task, and I believe you all are able to understand that how we can try to implement a bag of word. What is bag of word? What eventually it is trying to do? So technically it is trying to count the frequency, and based on that it is trying to convert your entire data into a vector space, right? And column name is nothing but it is going to be a unique word that is available inside your entire corpuses. So with that, thank you so much everyone. Take care and see you again in my upcoming lecture. Okay, so in my previous lecture, I was talking about count vectorizer, and I have shown you a bag of word technique, right? So bag of word technique technically represent this count vectorizer. Now there is something called as Engram concept. So there is something called as unigram, there is something called as bigram, there is something called as trigram. So Engram concept which exists. So let me share my screen and let me talk about that. So here, when I have shown you this example, so as you can see that we are not considering a grammatical structure of the data. We are not even considering that which one should come after what while creating a vector. So it's just a frequency based like a mapping we are trying to perform, and eventually we are trying to convert our data into a vector space, which is somehow not going to capture the context of the data properly, and it will end up generating a very weak vector which is representing the actual relationship between the data, right? And obviously if I'm going to send this data to my learning algorithm, it will not be able to learn it in an effective manner. So what people said that what if we can try to take a combination, right? What if we can try to take the combination of the data? And this is where the concept of n-gram came into a picture. A concept of n-gram comes into a picture. So I'll show you what in theory as well as I'll show you in a practical. So don't worry about that. Yeah. So here, let me share my screen with a coding. So let's suppose I have a textual information. So I have a text over here, and here text says that machine learning is fun. Yeah, machine learning is fun. Fine. This is my data. Now let me import couple of libraries. So from sklearn dot I have to import a feature extraction dot text. So out of this I have to import count vectorizer and then import pandas as PD. Okay. So this is the import that I have to do, and this is the data which is available to me. I'll show you one by one each and everything. So first of all, I'll try to show you with respect to a unigram. Yeah, I'll try to show you with respect to the unigram. So here, only unigram example I would like to show you. So only unigram. Yeah, only unigram. So how this only unigram by the way looks like, I have to convert this cell into a markdown. Yeah. So here only unigram, if I have to show you, so I have a data. So basically this text data I have, and here so I can try to call my count vectorizer, and then inside this I can try to provide n-gram range. So inside this count vectorizer itself you can try to provide your n-gram range. Now if I'm going to write 1 comma 1, what is the meaning of that? That's important. Yeah, we'll try to understand that part. So vector vec, and here so x dot vec dot fit transform I can try to call, and I can try to pass my textual information. It is going to give me an output, obviously. Yeah, it is going to give me an output. Let's suppose output is going to be x. So here I can try to call pandas dot data frame so that I can see the result in a very structured way. So x dot to array array, and that is going to be the column. Sorry, that is going to be the data, and columns is equals to what? So columns is equals to vector dot get feature name out. Now this is the data which I am able to find out. So here we had the information called as machine learning is a fun. So okay, machine learning is fun. It has created this like a unique combination, and here so it has labeled 1111 to everything, right? I have written n-gram range is equal to 1 1. Maybe you will not be able to understand with this one. Let me change this to 1 and 2, and now see the result. Yeah. Now let me copy the same part and let me change this to 2 and 2. Yeah, 2 and 2. Now copy the same part and let me change these things to 2 and 3. 2 and 3. Yeah. Now let's start doing the comparison, and now you will be able to understand the actual meaning of a n-gram. So here when I have written n-gram 1 and 2, so what it means? It simply means that try to consider the individual data which you have. Yeah, try to consider individual data. So fun is machine learning, all these things, and try to consider even all the combination of a 2 data, a consecutive combination of 2 data. So we have a textual information as what? Machine learning is fun, right? So machine learning is fun. So here machine learning is fun. So all combination you must be able to find out. So they have introduced this combination so that I will be able to decrease the I will be able to introduce basically some sort of a relationship between one and the other data set, that okay, so even this combination is possible, even this combination is possible, even this combination is possible, so that I can create my features, I can create my data in a best possible manner. When I say 2 comma 2, it simply means that only a combination of 2. Yeah, only a combination of 2. When I say 2 comma 3, so combination of 2 and a combination of 3, both is allowed. This is what it means. When I say 1 and 1, so combination of only 1 and only 1 is allowed. Yeah. So when I say 2 and 3, so you will be able to see a combination of 2, and then combination of a 3. That okay. So machine learning is, and learning is a fun, something like that, right? It is able to create with all the kind of overlap. So it's not very difficult, and this is something called as Engram approach. Yeah, Engram approach. So based on that, it is trying to build the data. This is ultimately trying to build a data. It is not doing anything else. So here, I think we all are able to understand the meaning of a unigram, the meaning of a bigram. Bi means 2, uni means 1, tri means 3, right? Tri means 3, and it's nothing but a technique by which I'm going to consider the combination of the data. As simple as that. Yeah. So combination of the data. So machine learning is, and then learning is fun, something like that. We are going to consider, and we are preparing the final data. So hope this engram is clear to all of you guys. With that, thank you so much, everyone. Take care and see you again in my next lecture. Okay, so welcome back to lecture once again, guys. Now in this lecture, I'll be talking about another vectorization technique, which is called as TF-IDF. So term frequency, inverse document frequency. So what is this term frequency? What is this inverse document frequency is? We are going to understand it, and we'll try to see it in a practical manner as well as into a theoretical manner. So let me share my screen, and let's start talking about it. So here, let's suppose if I have written TF and IDF. This full form is basically term frequency inverse document frequency. It's very simple. Yeah. So it's called as term frequency inverse document frequency. Yeah. Term frequency inverse document frequency. That's a full form of this one. So this is again another vectorization technique by which you can convert your corpuses, your data set, into a numerical representation. Nothing different. Yeah, nothing different. But it is a little bit different. So here, so in case of term frequency inverse document frequency, it will even try to reflect that how important a particular word is with respect to the word which is available into the entire document. This is where this term frequency comes into a picture. Means it will always try to show you that if some word is occurring more number of times, then maybe it is having a more weightage, or maybe it is having a more significance. And this is where this term frequency, document frequency is coming into a picture. Now here, so if I'll try to write down a term frequency formula, so term and basically like D, so document. So term frequency says that number of times T or terms appears in document D divided by total number of terms in a document. Total number of terms in document D. So this is what term frequency says. Now inverse document frequency, IDF, if I'm going to talk about, so this says that it's nothing but it's a logarithmic of basically a logarithmic of a total number of document D divided by basically 1 plus, so number of document D containing term T. Now this is the formula, and we don't have to worry much about the formula. Don't worry about it. I'll try to like approve that part. I'll try to show you that part. So TF-IDF is technically TF into IDF, inverse document frequency. Very simple, right? So TF-IDF is nothing but term frequency into inverse document frequency. So this is called as TF-IDF. This is going to be give you the final TF-IDF, which we are going to use it. Now, how we are going to use it? Let's try to understand that particular part with the help of one of the example, by the way. Yeah, one of the example over here. So here, let's suppose I have a data, maybe I have a document over here, and inside this document, I have a data called as I love NLP and machine learning. Fine. So this is one of the data we have, and the second data is, so NLP is fun. Yeah. Now, so what we are going to do? So we are going to create a columns. Now we are going to create a columns, which is technically a features. So features are going to be the unique number of the word in the entire corpus. So we have document number 1, we have a document number 2. So here we have I, we have love, we have NLP, we have and we have machine, we have learning, and then NLP I have already considered, we have is, and we have basically fun. Yeah. Now, so if I have to convert my document 1, which is this one, data 1, into its vector representation, so how I will be able to consider, how I will be able to convert. So first of all, what I will do is that I will try to find out a TF-IDF of this for a document 1, and then similarly for a document 2, and I will be able to convert it into a vector space. Now manually, let's try to find out a term frequency of I first of all. Yeah, only I. Rest we can do the calculation, so it's fine. We can try to use a programming. So here, if I have to find out the TF-IDF of I, so what will be the term frequency, inverse document frequency of I? So TF-IDF, first of all, try to find out TF of I. So number of times terms appear in the document D. So how many times I has appeared? Only one times in this document D, the first one, right? So only once, divided by total number of terms in the document D. So how many terms we have into this document? So 1, 2, 3, 4, 5, 6. So we have basically 6. So term frequency is basically 1 by 6. Now what is IDF, by the way? Yeah. So IDF. So IDF is total number of document. How many total number of document we have? Total number of data we have basically 2 divided by 1 plus number of document containing term T. So how many document is containing this term I, by the way? So how many document is containing? So only one, right? So here 1, and logarithmic of this. So basically log of 2 by 2. So log of 1. So what is a TF-IDF? What is TF-IDF, by the way? So 1 by 6 into logarithmic of 2. So this is going to give you the value of TF-IDF. As simple as that, right? So as simple as that, this is going to give you the value of TF-IDF. So just do the math, 1 by 6 into logarithmic of 2 base 10, and you will be able to find out the final value, and that you have to write down over here. Similarly for love, for NLP, for and, for this, and similarly for the other things you have to find out. Very simple, but yeah, no need to remember the formula. So we can try to do it even in a programmatical way, which obviously we are going to do it in my next lecture. So with that, thank you so much everyone, take care, and see you again in my upcoming lecture. Okay, so welcome back once again, guys. Now in my previous lecture I was talking about TF-IDF in theory. So now let's try to talk about this TF-IDF in a practical manner. So here what we can do, so we can try to share our screen, and we can try to create a file tf-idf.ipynb. And let's start talking about this TF-IDF, term frequency inverse document frequency. So I have to prepare a data first of all. So maybe my docs, I can try to prepare my data. So here I love NLP. So I love NLP and machine learning. Fine. So this is my document number 1. Then my document number 2 is going to be, so NLP is fun and exciting. Fine. So this is my second number and document, and then third number document, I love deep learning and AI. Okay. So this is my document which I am going to take. Now the second part is that you have to import the library, TF-IDF library, obviously, right? So from sklearn dot feature extraction dot text, by the way. So import what? So import TF-IDF vectorizer. Yeah. So this is something that you have to import. Very simple. Yeah. Now, so let's try to create an object of this vectorizer. So vectorizer object for like a TF-IDF, so that I can try to pass the data. And then this vec dot fit transform, not just fit, so fit basically transform. Now here, so if I'm going to pass my data, so which is available into the docs, it will be able to give me something, right? So 3/11 is sparse matrix, it is able to give it to me. Sparse means like a matrix with majority of the value is equal to 0. Now here, so let me store this particular data into like X data. Yeah, as a X data, I'm going to store it. And then if I would like to convert this entire data into a data frame so that I can show you the final result, I can do that. So maybe I can import pandas as PD over here. So pandas dot to data frame. So same thing I have done. So pandas dot data frame, and then here, so what I can do, I can try to pass my X data. So X dot to array, I can try to pass comma. I can try to pass columns. Columns is nothing but, so the vector that we have created, vector dot get feature name out. So it is going to give me all the feature name out. So this is something that it has created, guys, for my document number 1, document number 2, and document number 3. So this is the term frequency, inverse document frequency. You all will be able to find out. Yeah, you all will be able to find out. So for like this is the unique word that it has considered, right? This is the unique word that it has considered, and after considering the unique word, right, so it is trying to find out the term frequency, inverse document frequency. TF-IDF combinedly, it is able to find out, it is able to do the calculation. And I believe we have already seen that how calculation has been done. We all are aware about the formula, right? We all are aware about the formula. So finally, I'm able to convert my data into a vector space, and this data I can try to use for the further processing, right? For the further processing, I can try to use this particular data. Any kind of use cases if I'm trying to solve, maybe if I'm trying to do maybe a spam detection, or maybe if I'm trying to do a sentiment classification, everywhere I will be able to use this particular data, because this is the data which is needed. This is the data which is required for any further operation. So hope all of you are able to understand this TF-IDF. With that, thank you so much everyone. Take care, and see you again in my next lecture. Okay everyone, so now let's try to discuss about spam detection with the help of TF-IDF. So obviously TF-IDF is a vectorization technique that we are going to use, so which is going to help me out in terms of converting my data into a vector space with the help of TF-IDF technique, and obviously I will try to use some of the classification algorithm for the same. So let me share my screen, and here, so let me create a file, spam detection TF-IDF. So TF-IDF is just a vectorization technique I'm going to use, guys, nothing more than that. So here, let me write the code. So first of all, we have to import a couple of things. So first of all, let's try to import a sklearn dot sklearn, fine. So dot model selection, and then import train test split. Why I'm using it, I'll try to talk about it. So from sklearn dot naive bias. So naive bias is a classifier which I'm going to use, by the way, and then multinomial naive bias, and then from sklearn dot pipeline, I can try to call and import make pipeline. Okay, fine. So these are the import that we have to do. Maybe on top of this, you can try to do a import called as from sklearn dot feature extraction dot text from text. So import TF-IDF, sorry, not this one. So TF-IDF vectorizer, fine. So this is something that I have done as an import. simple, right? This is something which I have done as an import. Now let's try to prepare the data set, because data set is the ultimate thing that we have to prepare all the time, right? So here, if I'll talk about my X data, so my X data is basically when, let's suppose I'm writing when money now. So this is data number 1. Then limited time offer, and then there is something called as hello, how are you? Hello, how are you? And then let's suppose I have a data called as let's catch up tomorrow, and then buy cheap meds online, and then are you free today? So this is my X data, let's suppose. So this is my X data which someone has given to me, and then I have a Y data, which is nothing but a labeling of this data. So someone has already labeled this data. So let's suppose this data is been labeled as a spam data, right? So a spam data. Okay. Now limited time offer. So this is also like a labeled as a spam data. Now, so hello, how are you? HELL. Hello, how are you? So this data, hello, how are you, is a not spam data, not spam data, let's suppose. And let's catch up tomorrow. So this is again a not spam data. So let's catch up tomorrow, not spam. Then we have buy cheap meds online. So this is a spam data, let's suppose. And are you free today? So this is again not spam data. Yeah, not spam data. So now these are the labels that is given to all of this data. So this is my X data and this is my Y data. So technically what I will have to do is that I have to convert this entire information into a vector space. Yeah, vector space. And for that I can try to use a TF-IDF vectorizer. Fine. So TF-IDF vectorizer I can try to use, and based on that I can try to convert my entire data into a vector space. I believe we have already done that. Yeah. So TF-IDF vectorizer, and let me just show it to you that how my vector will look like. So VEC, and then this dot vect dot fit transform. I can try to pass my X data over here. So this is going to give me the X vector data. Fine, X vector data. So if I have to show you, so I can try to call maybe import pandas as PD in a structure way if I have to show you. And I have already shown you even in my previous a lecture, right? So how to do these things, how to find out, and how to showcase this entire information as a data frame. So here pandas dot data frame, and it is going to be X vector dot to numpy array, and column is going to be vector dot get feature name out. Fine. So this is, we had how many sentences? We have 1, 2, 3, 4, 5, 6. We had 6 sentences, and for 6 sentences, this is the TF-IDF vector I am able to find out. Yeah, this is the TF-IDF vector I am able to find out. So this is technically my X data, by the way. So this is my X data, and I have my Y data. Yeah, I have my Y data. So I have my X and I have my Y. So I can try to train the model. How I can try to train the model? So I will be training a model in a very simple way. That's the reason. So I have done the a make pipeline things over here. So here what I will do is that I'll try to call just a make pipeline, and pipeline wise. So first we have to convert my data into a TF-IDF. So here I have just shown you out of the box, right? That okay, this is how this data will look like. So make pipeline. So what I can do in terms of a make pipeline. So I can try to say that what operation I would like to perform with respect to the input. So a TF-IDF vectorizer, first of all, I'm going to perform. And then after that, try to pass this data into my naive Bayes algorithm. So naive Bayes is one of the algorithm for doing a classification. Those who would like to know more about naive Bayes, so please try to follow along in my machine learning chapters. Yeah. So over there, I have already discussed about these things. Now here, so this is the pipeline I'm trying to create. So first do a vectorization, means try to create this. Vectorization means actually this one will be created, and then try to send the data for the classification. Now here, so this is going to be my model. Yeah, this is going to be my model. Now I can try to call model dot fit, not fit prediction, model dot fit. I can try to pass my raw x and raw y. So whatever raw x and raw y that I had, so my x value and my y value, I can try to pass. No need to pass this x vector. It will be doing it automatically inside the pipeline. Now just try to execute it, and this is the pipeline it is able to create. So first it is going to vectorize it, and then it is going to basically perform the classification task. Yeah, classification model it is going to train. Now how I can try to test it, by the way? So for testing purpose, so I can try to call model dot predict, and here, so I can try to pass a data. So maybe I can try to say that free offer just for you. So let's suppose this is the data I have received, free offer just for you. Generally we receive this kind of information in our SMS or WhatsApp and email. So whether it's a spam or not a spam, let's see. So basically free offer for you, and it's telling me that it's not a spam for me. Yeah, based on the training, obviously we had like a very limited data, right? A very limited data. So based on that, it is not able to give me maybe a better result. Maybe I can try to pass something like a win money now. Let's see. So whether it is able to, so I can try to add win money now. So again, it is trying to predict win money now is as a spam. So if I'm going to increase our data, obviously my name bias is going to perform better and better. But the whole idea behind this example is to show you that after vectorization, what next? Yeah, so I can try to call maybe a machine learning algorithm. I can try to call maybe a deep learning algorithm or any other algorithm. I can try to train, and I can try to train this entire things by passing this particular data set, because this, unless and until you are not going to convert your data into a numerical space, you will not be able to perform these operations. So hope all of you are able to understand that how we can do a sentiment, or sorry, how we can do a spam detection, and where we are using vectorizer as a TF-IDF vectorizer. So with that, thank you so much everyone. Take care and see you again in my next chapter. Okay, so now with respect to a TF-IDF, let's try to understand how we can do a sentiment analysis. So it's not a big things, but yeah, I believe we should know about it. So here, sentiment with TF-IDF. Yeah, so TF-IDF is something that we are going to use it for a vectorization. So let's try to do a import. So I will be doing all the import which I have done in my previous one. I don't want to, like, rewrite the same code once again. So here, this is the import that you have to do, and we are going to perform the sentiment analysis. Yeah, we are going to perform the sentiment analysis over here. So here I'm going to prepare my X, by the way. So my X data is nothing but, let's suppose I'm going to consider this as a X data. It's already prepared. So I love the movie. It was a great experience. Worst movie ever. I hated the acting, brilliant storytelling, terrible plot. Yeah. So these are the different kind of a data. And then we have a label for that. We have basically Y for that. So we have positive, positive, negative, negative, positive, negative. So this is positive, this is positive, this is negative, this is negative, this is positive, this is a negative. So we have like a X data and we have a Y data. Now what we can do, so if we have to do maybe a model building, so obviously we have to convert this X data into a vector space. Yeah, so we can try to use a TF-IDF, we can try to use a bag of word, whatever we want, we can try to use it. So that we already know. We have already seen that in my like a past. So directly I can try to call a make pipeline and TF-IDF vectorizer. I can try to call. So everything will be handled by my system itself, because last time I have already shown you. And then like a multinomial naive Bayes I can try to call, and this is going to give me a model, MODEL model. It is going to give me. And then I can try to do a model dot fit over here, model dot fit, and here, so I can try to like fit my X data, and I can try to fit my Y data. So TF-IDF vectorizer, and this is the pipeline it is able to create. Simple, pipeline is able to create. Yeah, so pipeline is done. So it will try to do first of all like a TF-IDF, and then it is eventually will try to do a classification algorithm implementation. Then I can try to call a model dot predict, and I can try to pass some data. Yeah, I can try to pass some data. So maybe if I'm going to pass the movie was fantastic, so it is giving me a positive result. Yeah, maybe I can try to pass another data. So it was worst, so it was worst. It is giving me like a positive for that. Maybe I was like not able to make it explain that worst means negative, worst means not a positive. Maybe I can try to give this one so that it can understand in a better way. So worst movie, now a negative. Yeah, so basically all these things depends upon the data that we are going to pass. If we are going to pass a less amount of data, obviously it is not going to understand things in a better way. If we are going to pass a more amount of data, things will be better and better and better, and that is the same reflection you all will be able to find out over here. But yeah, so if we are trying to build like something like this, a sentiment analyzer, so I can try to build it with the help of TF-IDF, and then I can use any kind of a classification model within the same. So with that, guys, thank you so much. Take care, and see you again in my next lecture. Okay, so welcome back to lecture once again, guys. Now in this lecture, I'll be talking about a word to vector. Now word to vector is another method, another technique by which you can convert your entire data into a vector representation, or you can say into a numerical representation. You will be able to convert your data. The best part about word to vector is that whenever you are going to convert a data with the help of word to vector, it is going to consider even a semantic meaning of the data, and then it is going to convert, not like a bag of word or TF-IDF, so where it was trying to consider just a frequency or occurrences, number of occurrences of the data set. So now let me share my screen, and let's start talking about it in a practical manner. So word to vector is a model, I can say. So like a deep learning model, a neural network model, which people have already created it, and I'm just going to import it. Import it from where? From a gensim. So by default, gensim will not be available. So just try to do a pip install gensim gensim. In my system, it's already installed, so you all will be able to install it. Yeah. So pip install gensim, and it will be able to install it in no time. As simple as that. Now here, so if it is going to give you a problem with respect to NLTK, so just try to like do that once again, and it will be able to install NLTK as well. Now here is a sentence. So I love deep learning. Deep learning is a part of AI. Word embedding captures meaning, and I love NLP. So this is a sentence which I have taken. My primary objective is to convert this entire data into a vector representation. Yeah, into a numerical representation. So how I can do that? So let's like call the sorts, and then let's start doing it. So for I in sentences. Yeah. So for I in basically sentences. Why it is not giving me the auto completion? Okay, let me restart. Okay, so import, and then I in sentences. Okay. So what we are going to do is that we are going to convert the entire data into a lowercase, plus we are going to tokenize it. Tokenize it means we are going to break down the entire data so that I will be able to pass the data inside my word to vector neural network. Yeah. So word underscore tokenize, I can try to import. So here word tokenize, I can try to import. Tokenize, I can try to import, and then whatever data that we have, right? Whatever data that we have inside it, so we can try to convert that data to the lowercase, right? We are trying to normalize the data. Now, so we are going to store this data into tokenize sentence. Yeah. So inside this, we are going to store it. How my data will look like? So I believe we all know how my data will be like look like. So here a word tokenize, and this is how my data set will look like. So here word tokenize, I can try to show you my data. Tokenize, and then yeah. So this is how my data set will look like. Yeah. So I love deep learning. As you can see, there is a list, and I love deep learning. So all these things is been tokened. Means in a single word, it has been converted. Now again, so deep learning is a part of AI. So again, in a single word, it has been converted. Word embedding captures capture meaning. So again, in a single word, it has been converted. Again, into the single word, it has been converted. Simple, right? Okay. So this is called as tokenization. So we are able to tokenize our data. Now, so after tokenizing our data, so we can try to call a word2vec, a neural network, which we are trying to do an import from a GenSim library, and then we can try to pass our data. So we can try to pass this tokenized data because that will be the expectation. So here, word tokenize, we can try to pass as a parameter, right? As a parameter, we are going to pass. So sentence, I can give sentence is equals to word tokenized that we have done. Now, I can say that vector size is equals to 100. So vector size is equal to 100 means, so here we can try to control that what should be the number of the feature, or number of the column. So in case of TF-IDF, in case of bag of word, it was trying to take a number of unique word, right? It was trying to take the unique word. So we can try to control that over here. And there is something called as window. I'll try to give you the explanation about it. So let's suppose we are keeping window is equal to 2. And then minimum count is another parameter. So let's suppose I'm keeping at 1, and then there is a parameter called as SG, which full form is a skip gram. So skip gram is equals to 0. I'm going to give. Now, what is the meaning of this window is equal to 2? Meaning count is equal to like 1, and SG is equal to 2. Let me explain that part in a first. Okay, so what is the meaning of, by the way, a window over here? So when I say window is equals to 2, right? So when I'm trying to say window is equal to 2, it simply means that it looks 2 word before and 2 word after, right? So in terms of building a context of the entire information. So vector size is 100 means, so your entire dimension of this data which it is going to build, or numeric it is going to build for each and every sentence, is going to be 100. So if you have like a very high vector size, in that case again it will be problematic, because it is going to consume more and more memory. If it is very low, so maybe it will not be able to capture the context of the data. So here we are keeping window is equal to 2. Window is equal to 2 simply means that it looks at 2 words before and 2 words after the current word for building a context. As simple as that. Now here, so minimum count is equals to 1. So what I'm trying to say, that if there is some data which is not having a minimum count is this much, remove it. So let's suppose if I'm keeping minimum count is equal to 2, and if we have some sort of a token, so which is not appearing 2 times in my whole data, it will remove automatically. So as of now, I'm keeping minimum count is equal to 1. So even if data is appearing only 1 time, it will keep it, it will retain it. Yeah, it will retain it. So this is the, so basically it ignores all the word with the total frequency lower than this much. And then we are trying to give SG is equals to 0. So basically, when we are trying to call this word to vector, so it try to follow 2 things. One thing is basically CBOW, CBOW, continuous bag of word, and there is something called as skip gram, skip gram. Now, what is the difference between continuous bag of word and the skip gram? So continuous bag of word, right? If I'll talk about this one, so it will always try to predict a word from the context. Yeah. So it will always try to predict the next word from the context that you are going to give. And when I'm talking about a skip gram, so a skip gram will always try to draw, or always try to basically predict the context out of the word. Very simple, right? So a skip gram, let's suppose if I'm going to give love, so it is going to maybe predict the context. I love deep learning, right? And here, so if I'm going to give I love, so it will predict the next thing. So this is what a difference between CBOW and the skip gram you will be able to find out. Now let's move ahead, and let's skip gram is equal to 0 means I'm talking about a CBOW, by the way. So this is what it means. So here I can try to maybe store it as a model underscore CBOW bow. So continuous bag of words. So where I'm going to give a context, it should predict a next word. In a skipgram, it's a reverse of it. So I can try to keep all the things as same. So I can just try to change skipgram is equal to 1. So skipgram will be activated and model is equals to skipgram. Yeah. So this is one model. This is one model that we are going to build. And here, so we are going to pass, let's suppose, some sort of a data. So model CBOW, we are going to pass basically a word vector, and we are going to pass basically LOVE, love. Now, so it is going to give me some sort of a output. Dimension of this output is, so dimension of this output is going to be 100. Now, so if we are going to give a model dot word vector dot most similar. So here if I'm going to give love, so again it is going to give me some sort of output. So here, as you can see, so we are trying to give a love, and then we are trying to see that which word is most similar, or I can say like a nearby to this word called as love. So the nearest one is basically a word, then the second nearest one is part, and then an NLP, then capture, then meaning is, and so on, right? So this is something that we are able to predict from this skipgram. Now, whereas from this model.cwow, so we are trying to get a vector for this particular word. So we are going to get basically like a information out of this entire data. Let me show you so what this data is technically representing. So again, same thing I'll do over here. So what I have done are most similar, right? So here I can try to call WV word vector dot most similar, right? And then if I'm going to execute it, oh my bad, so I should pass that as a functional input. Okay. So here again you will be able to find out that in case of like a most similar for a love, if I'm using a CBOW is these data, and if I'm using a skipgram, again these data. Maybe it's a similar, right? It's similar to each other. That's completely fine. But at the end of the day, right? At the end of the day, so we are trying to find out a most similar. Not just that, so we are trying to find out even a representation of a one single word. So for example, what is the representation of the word love? So this is the representation of the word love. Now, so if I'm going to give, maybe if I'm going to give maybe my name Sudhanshu over here, will it be able to give me a representation? Obviously no. So because Sudhanshu is not available, Sudhanshu is not present in my original data set. So here you can try to pass any of this data which was already available, inside my data set, and for those data only it will be able to give you a vector representation. For example, if I'm going to pass embeddings and embedding was available, so it is trying to give me a vector representation that, okay, so in a numerical space, this is how embedding looks like. So when you are trying to use a word to vector CBOW, as simple as that. Yeah, so as simple as that. So it is basically trying to represent that how love is been used in the context, means how we can try to use love, or how we can try to use this embedding in this particular context, as simple as that. Yeah, so this is a 100 dimension representation of our embeddings. Similarly, so I can try to maybe find out and embeddings for all the other data as well. For example, a learning. So I can try to pass a learning, and it is going to show me that how learning actually looks like in a 100 dimension. Simple, right? Now I can try to control it. So let's suppose I don't want to represent this entire things in a 100 dimension. So maybe I would like to represent this with 10 dimension only, not an issue. So here, just with the help of 10 dimension, it is trying to represent the same data. So I can control it. Yeah, I can try to control it as much as I want. Very simple, right? Okay, so with that, thank you so much everyone. Take care, and see you again in my next upcoming lecture. Okay, so we have been talking a lot about embedding, because embedding is important for any kind of NLP task where you have to convert your entire textual information into a vector representation, but technically numerical representation, right? This is what we do. Now, like we have seen that most of the technique that we have been using, it's not able to capture a contextual information, right? It is not able to understand relationship between the data, between the word in a best possible way. So when it was trying to convert something into a numerical representation. And these techniques are basically a bit old technique as well. Nowadays, so we are not going to use those techniques. So nowadays we have a GPT kind of a model. We have a transformer based model. Now, what is transformer? Obviously, I'm going to teach you that in a very, very detailed way going forward. But yeah, so now we have a transformer based model. Now we have a models which is having a knowledge of the entire world, right? Knowledge of the entire world. And we have tons of such kind of a model which is available. So in a current situation, so when we try to look for the embedding, so we never try to follow this old approach. Obviously, old approach you should know, you should always be aware about it. But what we do is that we try to follow, or we try to find out a new approach by which I will be able to do the exact same task but in a better way, so that whatever like a numeric value it is going to generate, it should be able to retain the context. It should be able to maintain the semantic as well as syntactic information and a relation. Now, so that is something that we can do it with the help of transformer based models. Now there are like again tons of transformer based model which is available on a Hugging Face, as well as it is available on other platform, which is already a pre-trained model on a huge amount of the corpuses. But what we can do is we have a access of Uri, and inside Uri we have one of the best model access, which is basically a model from an open AI. We are going to use that model because obviously it's a open AI model, it's a transformer based model. So we can try to use it, and again without doing any kind of installation, we just have to call a API because we have exposed that as an API. And this is how we do a embedding in a modern world, right? In a modern world, this is how embedding is going to happen. So we are going to follow a modern world approach, a transformer approach, and that too even with respect to that API, and we can try to convert our data into a numerical representation. Let's see how we can do it. So here transformer underscore Uri dot IPYNB. It's very simple, right? It's very simple. Let me show it to you. So here, what we have to do is that you can go to a Euron platform. We all have access of a Euron platform. You can go to Uri API. Now, if you will come inside the Uri API, if you will check the model, available models, just come down and you will be able to find out that we have a embedding model which is available to us. A text embedding 3 small model from a OpenAI itself, which is going to give you any input data, right? For example, if I'm trying to give an input sentence, so it is going to convert that sentence into a dimension size or vector size of 1536. You must have seen that in a TF-IDF, it was a number of the unique data available across the corpus. Again, in a bag of word, it was same. In case of basically word to vector, so we were trying to control the vector size. So we can try to keep like be a 10, 100 or whatever we want. Now in over here, so 1536 is the final output it is going to give you for any kind of a input data. And you can try to store it. You can try to maybe do a similarity search. You can try to build a sentiment analysis, whatever you want, you can try to build it, because at the end of the day, I need my data to be available in a numerical representation by retaining, by maintaining semantic and syntactic information. As simple as that, right? So here, this is something that we are going to consider. Now, how we can use this model? Very easy once again, right? So you have to go over here, create a API key. Let me delete my previous API key. Yeah, so you can create as many API key as you want. So click on this and create a API key by any name. So here EMBEDDING embedding is the name which I am giving. So API key will be created. I can copy this API key. I can keep it somewhere. So maybe I can keep it here, right? So this is my Uri API key. And then what we can do, so we can try to use this embedding model. So code example also we have given to you in Python, JavaScript and curl. So here, this is the embedding, right? Embedding. So just copy this part and paste it inside your Jupyter Notebook. You don't have to do anything. So you have to just change this static, right? Just change this static with this one, simple. So change this static with your API key, as simple as that. So I have changed a static with the API key that I have copied, as simple as that. And API key creation is not a big deal. Now this function is going to give you the embeddings. So here generate embedding is a function. It is going to return the embedding. Embedding means representation of a vector space. So here I'm trying just copy and paste, right? You can use this function anywhere you want, just like a plug and play. And where we are using which model? OpenAI text embedding 3 small model we are trying to use. So here if I'm writing weather is sunny, it is going to return me the embedding. Name text 1 is not defined. Okay, so this should be like a text. Yeah. So now if you are going to check like this is the embedding it is able to create. Now if you are going to check what is the length of the embedding, you will be able to check that part as well. 1536, right? So here if I am going to pass a sentence called as my name is Sudhanshu. So it will be able to represent this my name is Sudhanshu as a embeddings, and you can check its embeddings over here. You can try to use this embeddings. Simple. So this is the best approach, a modern approach. So you should not follow all the previous approach, but yeah, to understand what is embedding, what we are going to do with the embedding, and what is the history of the embedding, obviously you must be aware about those things. But if I'll talk about a modern approach, so obviously you have to use a transformer model, and here we are using one. You can try to even download a model from a Hugging Face, because if you'll go on a Hugging Face, again you will be able to find out a multiple pre-trained model on a huge corpus of the data. You can try to use either that, or a simple one is going to be the URI. Call this function, pass your API key, right? Pass just your API key over here, and then pass the data. And for the data, you will be able to get your embeddings. Means you will be able to get a vector representation of your data in a dimension of 1536. So hope all of you are able to understand that how we can use a transformer based, or how in a modern world we try to generate the embeddings. So with that, thank you so much everyone. Take care, and see you again in the next lecture. Okay, so welcome to lecture once again, guys. Now in this lecture I'll be talking about RNN, a recurrent neural network. So see guys, we have already discussed about a neural network, and whenever we talk about a neural network, we talk about input, and then obviously it is going to update weights in a backward propagation, which is eventually called as learning, and then I will be able to get a output. That's completely fine. But whenever we talk about a neural network, it will not be able to retain anything from a past. Simply means that every time whenever we try to pass an input, so that input will be disconnected from the input or the output that we have given before, right? And it is going to create a problem. So what kind of problem it is going to create? So basically, whenever we try to talk about textual data, whenever we try to talk about a speech or time series based data, over there, obviously there will be a dependency with a past. So whatever we have done in a past, we have to propagate, or we have to put, or we have to give even that information. Unless and until that information is not available, it will not be able to use the past information or the past memory, and based on that it will never be able to give the output. So every time it is going to technically give the independent output. Now this was a problem. This was a problem with respect to a neural network, and this is where, so researchers have introduced a network called as RNN. A full form of this RNN is basically recurrent neural network. So RECURRENT, recurrent neural network. So they have proposed, basically, they have proposed that what if we are going to pass not just a current input, but we can try to pass something even from a past. In that way, we will end up building a memory, or in that way, we will end up providing a previous context to a network. And obviously, when network will try to give me an output, So it will try to consider my previous memory or my previous input or my previous learning as well. It is not going to consider my current input as an independent input. And this is where the concept of a recurrent neural network comes into a picture, which you are going to use to solve multiple problems with respect to a text, with respect to a speech, or with respect to a time series. So wherever we have our dependencies with respect to a past, right? For example, if I'm going to write maybe a line called as I love machine, right? And then dash, 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 dash. So obviously I have to do a fill in the blanks, right? So maybe my network is supposed to predict that what is going to be the next word. Now, whenever my network is supposed to predict what is going to be the next word, obviously it is supposed to consider the previous input. Unless and until it is not going to consider a previous input, it will not be able to give my next output. And this is where the phenomena or the concept of this neural network comes into a picture. So they said that okay, so whenever you are trying to design a neural network, for example, I have an input over here or input layer over here, and let's suppose we have a hidden state, and let's suppose we have an output layer. Fine. So I believe we all understand this particular part in terms of a neural network basic. I have already discussed about it, and if you have not gone through this entire concept, so please try to watch my previous lecture where you will be able to find out a complete end-to-end derivation in a detailed way for a forward propagation as well as for a backward propagation. So here, let's suppose I'm trying to design this neural network. Obviously, I will be having some input. So let's suppose I'm trying to give input as x1, and I have input as x2, and I have input as a x3. So every time I'm going to pass this input, and obviously it will go through my hidden layer, or you can say my hidden network. Just do all the connections, and then eventually I will be able to get the output is equals to y hat, let's suppose. Yeah, y hat. So I'm trying to give some input, and then I'm going to get some sort of a output over here. That's cool. That's completely fine. But here, so whenever I'm trying to get a output, there is no dependencies between the previous input, right? So let's suppose I have passed a value of x1, x2, x3. I will be able to get y. That's cool. That's completely fine. But next time, whenever I'm going to pass a new value of x1, x2, x3, for example, I love machine. This is something which I'm trying to pass over here. It won't be able to understand that what I have passed last time. And if it is not able to understand what I have passed last time, it will not be able to consider it. Simply means that we are not building any kind of a memory. Now, what people have proposed over here. So they said that okay, so maybe we can do one thing. So we are trying to pass the current input. That's cool. That's completely fine. But what if we can try to pass some input even from a past learning? What is the meaning of it? Yeah. What is the meaning of it? So maybe, right, this was the proposal basically. So maybe what we can do. So here, let's suppose x1 at time t, 2 at time t, 2 at time t, right? And then here, so we have a hidden state, let's suppose ht, and then y at time t we are going to get. Now next time, right? As of now, we are living into a current situation, time t, yeah. Now next time, whenever I will try to pass x1, x2, and x3, yeah, x1, x2, and x3 over here. So what we are going to do, so maybe we can try to pass this one as an input, right? So we can try to pass this one as an input when this will be t plus 1, t plus 1, t plus 1 means next time. So this was a hidden state output we are trying to pass into a next state, and obviously it will be a part of your entire neural network. So next time, whenever you are going to get y t plus 1 at time t plus 1, whenever you are going to get the output, so as you can see, we have passed a previous input as well, a previous hidden state output as a input. Yes. So previous hidden state output as a input we are trying to pass, and obviously this will be having an idea, this will be having an understanding, because ht, when we are going to get this hidden state, whenever we have passed x1 at time t, x2 at time t, and x3 at time t. So basically, this will be having an idea that what we have passed, and with this, we are trying to pass it in a current state, right? At even time t plus 1. So we are trying to pass ht, which is going to be the previous hidden state value. So in this way, it will be able to build a memory. Yes, in this way, it will be able to build a memory. It will be able to understand that, okay, last time this was something which has been passed, and next time whenever I'm trying to give some sort of a output, so let's try to consider even a previous input. And that was the whole understanding about a recurrent neural network basically. And in this way, you will be able to solve a speech problem, you will be able to solve a text problem, you will be able to solve eventually a time series based problem or time dependent problem. So where previous input is required. But again, there was a problem. The problem was very simple. The problem was that when your input is going to be very long, right? When your input, or again and again, you will keep on passing the input, and obviously in a backward propagation, it will try to even learn. It will try to adjust the weight in between. So when your context or when your memory will keep on increasing, or you are trying to solve some problem, so where your context is very long, so in that case, it is going to face a vanishing gradient problem. What does that mean? So vanishing gradient problem means it will not be able to retain, or it will not be able to adjust a weight with respect to the very long context or long memory, you can say in other words. And that was a problem that we have been facing. And to solve that problem, people have introduced a network called as LSTM, long short-term memory, or you can say another network called as GRU, a gated recurrent unit, basically. So this was again another variant of a RNN. You all will be able to find out, which I'm going to discuss in your upcoming lecture. But yeah, so as of now, I believe understanding about a recurrent neural network is pretty much clear to all of us. In my next section, so let's try to talk about LSTM, and let's try to talk about gated recurrent unit network separately in a separate lecture. So with that, thank you so much everyone. Take care, and see you again in my upcoming lecture. Okay, so welcome back to lecture once again, guys. Now in this lecture, I'll be talking about one type of recurrent neural network, and that is going to be LSTM, long short-term memory. So in my previous lecture, I was talking about a recurrent neural network. So whenever we have to memorize something, whenever we have to retain something from a past, obviously this RNN will come into a picture, but there was a problem with the vanilla RNN, a vanishing gradient problem, or maybe a exploding gradient problem. And because of that, it will not be able to remember, or it will not be able to learn for a very long context. Now, so researchers have introduced a new network, and where they were trying to control it. They were trying to build a neural network which is going to help me out to even retain a long memory by eliminating a vanishing gradient problem or exploding gradient problem. And this is where this LSTM comes into a picture. So let me share my screen, and I have already designed this network for all of you. So that directly we can get into a discussion. So here, as you are able to see, that this is architecture of a LSTM, and it looks a little bit scary in a very first place. But I'll try to explain you each and everything step by step by giving you a formula or by giving you an example. So basically in this neural network, if you will closely observe, so we have a multiple gates. One gate is basically a forget gate. Let me remove this part. Okay, so basically this is going to be FT forget gate. Now we have an input gate, we have an input node, we have basically a output gate. Now, what and all things these gates will be able to do? Let's try to understand. So here, first of all, gate understanding. Yeah. So we have a multiple gates over here. What forget gate will do? So basically, forget gate is going to help me out in terms of what to forget or what to throw away. Throw away, basically. So this is where this gate is going to help me out. Now there is something called as input gate, and what input gate is going to do? So it is going to learn, or it is going to adopt that what new information to save, what new info to save. And then there is something called as cell state. Cell state. Now what this one is going to do? So basically this is a kind of a notebook, I can say. So this is a kind of notebook that carries memory across time. Yeah. So this is something that it is going to perform. And then you will be able to see output gate, by the way. And now what this output gate is going to perform, obviously it is going to give me the output. So here it will be able to understand that what part of memory to use now, means whenever it is trying to give the output. So here people have introduced this 4 entities. So one is, and you can say 3 gates technically. So one is a forget gate, and it will always try to adopt that what to forget or what to throw. And there is an input gate. It is going to understand that, okay, fine. So what new kind of information that we have to save? There will be a cell state, which is going to maintain the memory, just like a notebook. We try to take a notes, right? In the similar manner. And there is an output gate. So basically it is going to understand that, okay, fine. So I'm supposed to give the output, but to give the output, what part of the memory I'm supposed to use? And this is where this whole neural network fundamentals will come into a picture. So here on this top part, you must be able to see a cell state, right? So here we have basically a cell state, CT, right? CT minus 1 and then CT. So this is going to maintain my memory. So this is going to behave like a notebook. But with respect to the cell state, you must be able to see that we are trying to attach this forget gate, and we are trying to attach even the input gate. So forget gate, what it is going to do? So obviously forget gate is going to help me out in terms of offloading the memory, or you can say in terms of forgetting the things that is required. Because everything you can't keep it inside the notebook. Your notebook size is going to be bigger and bigger and bigger, and it will be very, very difficult for you in a future to find out a relevant information. So keeping that in mind, we have a forget gate over here, a small neural network, and we have an input gate. So whatever information will come, so we have to update our memory, means we have to update our notebook. So we have to even erase something from the notebook, and we have to basically update something inside the notebook. So this is where these 2 gates is going to behave. And then we have an output gate. So obviously what output gate is going to perform? So output gate is going to give me the output, as simple as that. Okay. Now, so here you must be able to observe that we are trying to take the input. Now, as we all know that in case of a RNN network, so we are not just going to get a current input, we are going to get even a past hidden state output as a input for the next step. And keeping that in mind, you must be able to see HT-1. So HT-1 is nothing but the output that is coming from the hidden state. The previous output we are trying to consider as an input. So technically we have 2 input. One is X at T time, this current time, and then another one is basically the output from the previous one, right? Previous hidden state. And we are going to update this neural network. We are going to update this neural network, and eventually I will be able to get the final output. So whatever prediction that we are trying to do, and which is going to help me out in terms of predicting a next text, or in terms of doing a sentiment analysis, maybe positive, negative, or kind of a neutral. This is going to help me out to understand the speech. This is going to help me out in terms of predicting something based on the time series, right? Based on the time series. So now let's try to write down the formula that what kind of a equation we can try to write for each and every gate. So first of all, first come first, a forget gate, right? Forget gate. As you can see that there are 2 inputs, right? There are 2 inputs which is going into this neural network. Okay. We have a sigmoid function over here. So which is going into the neural network. And then this is going to multiply with the memory or cell state, you can say. So here, if I have to write the equation for a forget gate, so let me write it down over here. So first one is basically forget gate. So if I have to write down this equation for a forget gate, so basically forget gate at time t is going to give you a sigmoid, and here, So we have two things which is getting inside, right? So we have a neural network. Technically, it's a neural network, right? So we have two things getting inside it. So one is a HT and basically we have a XT. So obviously weight of this for gate and it will be having technically HT minus 1 and X at time T plus a biases of the for gate. So this is going to be the equation for a for gate by the way. Now similarly, so if I have to write down the equation for a input gate, so basically inside the input gate, again, two things is coming into a picture. So here hidden state at T minus 1 and the current input that we are trying to provide. So here, if I have to write down the equation, so IT, so basically for this one, this as an output, so IT, it is going to be a sigmoid, right? It is going to be the sigmoid and then W wait for I. And here, so HT minus 1 we are trying to pass and XT we are trying to pass plus we are going to pass basically biases for the input gate. So this is something that I will be able to get. Now here, so we have basically, right? So we have basically input node as well. And we are trying to denote it as a delta of CT. So delta of the cell memory by the way. So here delta of C memory, as we can see, so it is getting inside the tan H, hypertangent basically. So tan H, right? Tan H and wait for this cell and then we can try to write HT minus 1 and XT will try to get as an input plus biases for a C. So whenever I'm writing this equation, guys, so basically it's a equation of a neural network. I think we all understand that part, right? We all understand that part, that if we have a neural network and if it is getting into the hidden layer, so obviously there will be a weight 1, there will be a weight 2, there will be a x1, there will be x2. So the total input which will go inside this one, let's suppose we have a sigmoid function. So the total input which will go inside this one is x1 w1 plus x2 w2. And this is something which will go inside the sigmoid plus biases, obviously, right? Plus biases which will be attached over here, biases. So same thing, same kind of equation we are trying to write down even over here. Very simple. So it's nothing fancy by the way. Now, so here we have basically a cell state update. So we have to update this line. We have to update this notebook by the way, right? Where we are trying to keep a note. So here, if we have to update this notebook, so maybe I can try to write the equation. So equation number 3, let's suppose a cell state update. Now, what we are going to do by the way with respect to a cell update. So here we are trying to multiply, you can say, so we are trying to multiply this FT with CT minus 1. So here we are trying to do a multiplication so that we'll be able to forget. So here if we have to update a cell state CT, this particular entity, so here it is going to be a for gate into this one, into CT minus 1. So for gate at time T into CT minus 1 plus. So we are trying to perform this operation as well. So plus, I would say, the input IT that we are receiving. So let's suppose IT is the input and then C delta T. So input IT into C delta T we are going to update, and this is going to maintain my cell state. This is going to update my notebook by the way. And here, so last but not the least, so we have to write down for a output gate. Now what I will be able to get as an output. So obviously if you will look into the output gate, if you look into this one by the way, so here you will be able to find out that output is nothing but the input. Yes, the input that we are trying to pass over here. So it's nothing but a sigmoid of and then over here, so wait for the output and here, so HT minus 1 and XT will get as an input plus biases for the output. So this is going to be the output. Yeah, this is going to be the output. And last but not the least, so we have to even update our hidden state. So what is going to be my hidden state output by the way? So here to update my hidden state output, I have to draw one more thing. So what is that thing that I have to draw over here? So this is the output that we are getting, right? And obviously we have to consider this even output and the memory as a hidden state. So here what we will do, so we'll try to put the multiplication and then from here, so there will be a tan H which will come and it will get into this, and this is eventually going to give me the HT. This is going to give me the HT. Now what is going to be the equation of HT by the way? So the output right? The output. So output will get over here. I'm multiplying with what? So multiplying with a hypertangent of a CT. So here the hidden state HT, which is going to be the input for the next label or next step, I would say. So it's going to be my output into, right, into tan H, and here, so we are going to pass a CT. So this is going to update my hidden state, which will be eventually the input, one of the input for the next state that we are going to pass. So this is how this entire neural network has been designed, by the way. Hope all of you are able to understand the architecture part. Gate by gate, if you will see and if you will try to check, so you will never be able to forget. And in an interview, so people are going to ask you a question that what is a responsibility of a forget gate or input gate or maybe a cell state, or how you will be able to get the output, or how you will be able to maintain the hidden state, and everything you will be able to see inside this architecture. So with that, thank you so much everyone. Take care, and see you again in my upcoming lectures. Okay, so welcome back once again, guys. In my last lecture, I was talking about LSTM, which is one kind of a recurrent neural network. Now, in this lecture, I'll be talking about another kind of a recurrent neural network, which is again going to simplify a previous network, which was LSTM. So where we had three different kind of gates. So here we are going to shrink that into two different kind of gates. So which is going to make my process faster as compared to LSTM, but still it will be able to learn and it will be able to memorize. And this is where this GRU, a gated recurrent unit, comes into a picture, as you can see, right? So this is basically a diagram. This is basically architecture of a gated recurrent unit. Now, how this is going to work, by the way? So here you will be able to observe there is something called as update gate. And then here you will be able to observe something called as a reset gate. Now, what this update gate is going to do? So update gate is going to decide, as its name suggests, right? It is going to decide that how much past information we are supposed to keep. This is something which update gate is going to do. And there is a reset gate, RT, that you are able to see. So which is going to decide that how much information, past information, by the way, we are supposed to forget. And then we have a candidate hidden state in between. So let's try to understand this with the help of equation, that how it is going to update the things. So here, first of all, let's talk about a gate which is available over here, which is nothing but an update gate. So here, update gate. Let's see how it is going to work, by the way. So here, let's suppose we are talking about this update gate, and as you can see that update gate is trying to take a input. Now, input wise, it is trying to take a previous hidden state input and then a current input. So obviously, it is going to take two inputs, right? As it's suggested in a diagram. So it is trying to take technically two input. Two input is coming over here, right? Inside this update gate. So here it is going to produce a Z of T in this place. So it is going to produce a Z of T, which is nothing but an update I'm talking about. So which is nothing but a sigmoid. So input ST minus 1 and XT, which get into this sigmoid, which is a hidden state, right? So here it will go as this one. So W of Z, and then it is going to take HT minus 1, and it is going to take basically X at time T, fine. So this is something that update gate will be able to take, and then it is going to decide that how much past information it is supposed to keep. And here, so when it is going to keep or when it is going to update. So technically when Z of T is approximately equal to 1, right? So Z of T approximately equal to 1. So it will decide that keep the old memory, keep the old memory. Yeah, keep the old memory. And when Z of T will tends towards a 0, or it will be closer to a 0, so in that case, it will try to update new memory. Update with the new memory means update a memory with the new information. This is what it means. So based on Z is equals to 1 or closer towards 1, or based on Z of like a closer towards a 0. So it is going to decide that whether we should keep a old memory or we should update the old memory. Parallel to that, so we have basically a reset gate, right? We have a reset gate. And again, if you will observe, so we are going to take two inputs inside a reset gate. So one is a HT minus 1 and one is basically a current input we are going to consider, which is similar to the update gate. So here, if I have to write a formula about a reset gate, so reset gate. So here this RT is nothing but approximately same as the z of t. So it's going to be a sigmoid of weight of r, h t minus 1 and x of t. Yeah, so this is something which reset gate is going to consider. And when it is going to reset, so whenever rt will be closer towards a 0, so it is going to decide that forget the previous memory. And whenever rt will be closer towards 1, it will try to take a decision that keep memory, keep the previous information. So we have two gates, update gate and reset gate. And again, obviously we have just two gate over here. In case of a LSTM, we had 3 gates. Now, there is another component that you will be able to find out, which is a candidate hidden state. Now, what candidate hidden state is going to do? So candidate hidden state is going to combine a reset memory and a new input, right? So candidate hidden state is going to combine the reset memory and plus hidden input. So here, if I have to write a formula for h of delta of t, so it is going to be hypertangent. So tan of h, and we are going to get input, right? So we are going to get a input as what? So we are going to get a input, right? So we are going to get a input as a reset, as you can see. So it's coming from here. It's coming from here, and then reset is coming from here. We are trying to do the multiplication, and this is getting here, right? This is getting here. So here, W of reset, R of t that we have written, into h of t minus 1. This is something that we are doing here in this place, right? And then we are sending this one inside a hypertangent. So this is what I have written over here, right? This is what I have written over here. And it is going to take what? And it is going to take the current input as well. So this is going to be the formula for this candidate hidden state, which is going to combine this reset memory and a new input that we are trying to send. Now let me clean this up, this entire things. Yeah. So now we are able to build a complete formula for a candidate hidden state, and we are able to build a formula for a reset gate and an update gate. So obviously in case of a candidate hidden state, this reset is also playing a major role, right? This reset is going to play the major role. That's the reason. So we say that candidate hidden state is basically a combination of a reset memory plus a new input that is coming into a picture. Now, moving to the next. So here, right? So here we have a hidden state HT, and how this HT will be updated, by the way. So we have a hidden state HT over here. And this looks a little bit like a tricky in this particular place. We have -1 over here. So if I have to write down the formula of HT, which is going to be the final hidden state, which will be the input for the next basically lap, or you can say input for the next iterations when we are going to pass the new value of x. So this will become ht minus 1 into a next state, right? Which is going to basically help me out to propagate a memory. So this ht, right? ht over here is nothing but 1 minus, as you can see, 1. So 1 minus z of t into, right? Into this one we are going to get. So this is going to be the final ht. So let me write it down in a neat and clean way. And again, you are not supposed to remember much if you are able to understand this architecture. So here this is going to be, so till this part, it is going to be 1 minus z of t. Fine, 1 minus z of t into, right? Into 1 minus z of t into ht minus 1. So ht minus 1, ht minus 1 plus over here. So z of t into h of delta t. So here plus z of t into h of delta t, which is nothing but a kind of hidden state. And this is going to build basically my final memory, right? So it is going to blend basically a old memory and it is going to blend with the candidate state. And this is how it will be able to retain the final memory for me. So hope all of you are able to understand this one. So here technically we have a reset gate, we have a update gate, and we have a hidden state. So reset gate obviously try to erase the old irrelevant nodes or the memory that you have built. Update gate, so it is going to decide so whether to overwrite or keep the old memory itself. And hidden state, So basically it is nothing but a notebook which you are trying to evolve, or you are trying to update it again and again and again. And this is going to build a GRU, gated recurrent unit. So where number of gates are less, means number of networks are less as compared to LSTM. So it is going to be faster. It is going to be faster as compared to LSTM. And it was introduced, I believe, if I remember correctly, in 2014. So it is one of the recent in this particular series you will be able to find out as an architecture which has been designed to understand or to memorize something, and based on that give you the next output. So with that, thank you so much everyone. Take care and see you again in my upcoming lecture.